to the beach?
Last Saturday?
You've been to the
Maybe
beach last Saturday,
Friday?
right?
Friday? I don't.
When you look out to the, did you look out to the water? How much view have you got of the water? Is it
No, it was evening. We were sitting there eating.
Open water?
I know what horizon is, and I know it's not flat, it's not a plane, it's not a line, and you can't have anything perpendicular to it.
Fair enough.
If you also approximate it as a line, okay, we can agree on something. But then it will be a line. Is it a curved line or a straight line?
If you were to name the left-hand side the horizon A and the right-hand side B, then let's say the tide. Let's say there's no tide in the slack water. No tide, so there's slack water.
Which side of the horizon is closer to you?
I've been to the water. I've been on the water fishing, and it's like literally mill pond at sea. No waves at all.
I've asking you, which
pretty
is closer to you? Your left side, your middle side, or your right side?
What are you talking about now?
The horizon.
What do you mean left? What are you on about?
You have a horizon goes from left to right. Which part of the horizon is closer to you, which is further away?
Depends on what you're looking at. What are you looking
the horizon, at? The whole horizon. I follow it from side to side. Which part of it that I look is closer to me, and which part is farther away from me?
It looks like a straight line to me. That's all. When I look across, I just see this line.
If it's a straight line, by geometric laws, one point will be closer to you and the other will be farther away. You look at your wall, you look to the left side is farther away from you, the middle is close to you, and the right side is again farther away from you. That's a straight line.
Yeah, so if you hold a level up, a spirit level.
So if you look at the horizon, which part of it is farther away from you?
What does that matter? Doesn't mean anything.
Because it makes it a straight or a curved line. That's what's important.
What are you talking about? I'm looking out to the
horizon is farther away from you from the other, then you're looking at a curve. Can you have a perpendicular to a curved line?
Sorry, Jakey, can I just confirm that? We are live, by the way. Can I just confirm that you said if you have a straight line and you're looking at a straight line, one part of it is closer to you than another part, so therefore it is curved?
Absolutely, yes.
But it's a straight line.
If it's a straight line, part of it should be closer to you.
Sound like...
And part of it, the only thing that is the same distance to you is when you're at the center of a circle, and the circumference, it is the same distance for you at any direction. That's a curved line.
But it's a straight line.
So first we need to investigate, is the horizon a straight line or is it curved? Because you say you can't have perpendicular to a curve, right?
It's horizontal, Jakey.
Can you have a perpendicular to a curved line?
No.
So we need to investigate, is the horizon straight or curved? If it's curved, then spot on just plots is a proof that the plumb is perpendicular to the horizon.
Vertical is perpendicular to the plane of the horizon.
He has a chance. He has a chance if the line is straight. But then we will need to identify which part of the horizon is closer, the left side or the right side.
Is a horizontal straight, Jakey?
Horizontal is defined as straight.
What, like the horizon?
No.
Okay. Can we relate the horizon to horizontal in any way?
Horizontal. I didn't say horizon.
Similar.
Is Pepper here yet? We're live.
Asking that.
I don't know. Yeah, we are live, Jakey. When do you want to do your thing? Wait for a few more people to come.
Wait.
It's still only dead early. They're used to the Buster song.
I need a word for my sponsor. Guys in the Blue Marble server, I apologize. I came here without any permission.
I say there's not enough people here yet. Wait for a few more people to come, and then
the video is there. I'm apologizing. The video is there. I'm apologizing for my sponsors that I came here without any permission.
Okay, you didn't check up with the Blue Marble scientists.
None. No one approved.
Okay.
That's like us not checking with them on the script. I mean, that's
well,
bad,
that's your problem, not mine. I deal with mine. You deal with yours.
It's bad juju.
Quick. Get over yourself.
We were just getting a little bit of a warm up, weren't we? Because we're going to go over this perpendicular thing. Betty's brought
You're not going to play a song or something?
And we're going to be going over Betty's perpendicular argument and the aporema that's the model-induced aporema that comes from the perpendicular argument that causes confusion of anybody with the model affliction. In fact, the more severe the model affliction, the bigger the problems they have. Some people even revert back to straight lines, not being able to relate straight lines to straight lines. Some people even want to curve them. So that's what we're going to go over tonight with Chaiki's help. So welcome, Chaiki.
I didn't say I'm here for help. I'll participate. Yeah. If it helps you, better.
Okay, let me just get this screen up then. So how's everyone been? Had a good week? We've had a week off. Everyone been all right? Do well without us? There's enough drama going on, isn't there? Right, let me get this.
Seriously, my dog is sleeping here. Sound happy to be near me. Don't know how bad things are. Post the link to your channel. I wouldn't find it on YouTube myself.
91
to the show,
replies.
I mean.
See what I can do.
It's on the air. Are you listening into the YouTube, Chaiki?
I don't have the link. I wouldn't find it.
I put the link in the live chat just a minute ago.
What website? I told you I wouldn't find it. Post it in chat.
I did, Chaiki. That's what I just said.
Well, I don't see. I see my dog pictures here. No video.
Right, I've got Betty's argument here and everything, so I don't know whether you guys can go see it. Let's see if I can stretch it, make it a bit better. Get this screen on.
Which text the link is? I'm on live chat.
I don't know. Yeah, Busty's just put it there in the live chat. On the live chat, I'll put it in the YouTube as well.
That's not your live video, is it?
No,
Up
you
top,
asked
there's a
Buster, didn't you? Did you not
No,
just
this
ask
for
Buster for his YouTube?
No, I asked you for your show.
It's already in there. It's a little bit further back.
It's also on the upper part of the server where it says YouTube. There's a bot that posts a link.
Yeah. It's called Model-Induced Aporema. Can Euclidean logic be undone by flat Earth mathematics and the dogmatic?
Okay, I got it.
proofless
It doesn't look
dogmatism.
like your normal.
Yeah, I know. Yeah. Changed it, innit? It's a special. Thanks for being here.
Okay, so I have the YouTube and I have this.
Yeah, this is going to be groundbreaking. This going over simple logic. If then, you know, I feel a bit ago there was they dabbled in logic, and they still think that they have, but I don't think that they simplified it. They didn't do the true advanced simplicity of logic, which is what we obviously do. Simple logic. So what we've done, there was a little bit ago, people tried to dabble with a modus tollens, a really old argument from antiquity. Well, what we're going to go over tonight is the modus ponens, proof positive, affirming the antecedent. But Betty does it a little bit differently, so let me get the Betty's argument.
I thought I'll get promotion. Someone said I'll get promotion here.
Somebody get the promotion.
On the show you'll promote my channel.
Yeah. There's only 16 people watching now. You want a few more, don't you? Or do you want to...
The video will be there.
The what?
People will watch it offline. They'll see it.
Okay, well, yeah, I'm saying, like, now, do you want to do a promotion for your... Have you got any, like, headers? Have you got a channel name? Have you got anything you want to post into the,
sure, I'll give you the
live chat?
Hold on.
Shikey's back, everyone. What he's done is he's had to make a new account because his other account was banned from this server. So he's made a sock account to avoid the ban. And now he's doing a promotion. He's got a Discord channel. I think he's entering the arena. He's obviously seen that lack of interest and it's dwindling a bit. So Chikey's doing a Discord channel. I don't know whether he's going to go live and go the full YouTube sort of thing, or whether he just wants to talk to people on the internet. I bet that's what it is, Chikey, is it? You just want people to talk to? I think Johnny B made a server.
Yeah, just people to talk to, but whatever they want to talk to.
Yeah. The non-scientific asylum, is that it? It's there. That's what it's called. Have you not got any other promotional stuff? Have you not got any, like a flyer or anything? No artwork? No taglines?
No whistles.
No. What's your biggest thing then? What's your
no moderation. No moderation.
No moderation. There you go. There's an advertisement for you. Chikey's not going to bother moderating. So it's a Discord server where you can talk to people. No. And are you saying that you're not going to moderate people? Like you're not going to hit the mute button or anything?
Unless it's out of line. Unless it's out of line. If it's out of line, yes. But otherwise, free to say whatever you want. Your opinion, welcome. You want to pick up a fight? Pick up a fight. I don't care.
Yeah, free for all Friday. That's what we do here, especially on Fridays. So some sort of like this, where you just invite people over to have a chat. Come on in.
Yeah, like this hangout, but I hope it will be bigger.
Well, I hope so too. There's not many people that really want to come and have a chat. I've noticed.
Yeah, I know people are shy to talk because when they go out in the real life, they don't talk. They type.
Well,
seriously, everyone see your face outside. Can take pictures of you, and here they become shy.
I posted your Discord link in the YouTube, Cheeky.
Thank you very much.
Thank you, Kevin. In the spirit of what we do here, modern science, is there proof or no proof? Because I've noticed you've called your channel non-scientific. So is there proof within science or modern science, or is there not proof within science?
Yeah, we don't make laws anymore.
Okay, so is there, in your mind, is there proof within science, or is there no proof within science?
No proof.
No proof. So non-scientific would be not no proof, i.e. proof. You talk about proofs.
No, it means that it's not scientific.
Yeah, and scientific is no proof.
So
if you were to have proof, that would not be scientific.
What scientific is irrelevant.
Definition of modern science.
No, what scientific means is significant, not what it is.
Yeah, but if we were to have a proof, Cheeky, would that be scientific?
Of course not. If there's no proof in science, it can't be scientific if it's a proof.
Okay. So if we have a proof that the Earth's not flat, that, by your standards, could not be scientific because it's a proof.
But you don't have such a proof that it's not flat.
Well, we can't have a scientific proof, obviously.
You don't have proof that something is not flat. You made up a definition and you go by it. That's not how the world works.
I made up a definition.
Yes, you did.
No, I go with the definitions and
let's see the definition, Bev. Let's see the definition. I want to see it.
Definition of what?
Flat.
What? I'm not claiming flat. I'm claiming not flat. So therefore, I don't have to define flat to say not flat.
I think Chike wants to argue for flat. So
I think he does, yeah.
No, I want to argue that when you talk, you need to talk clearly.
Yeah, but even I don't.
In order to know, let me finish.
How ironic. In order
to know what not flat is, I need to know what flat is.
I don't even claim flat. You're hilarious, Cheeky.
Go on, Emma. I think the guys will let you talk now.
No, it's not. I don't think I want to speak to Chike anyway. I mean, he's trying to say that people weren't speaking clearly when obviously he's never listened to a recording of himself back, has he?
Love you too, Emma.
Mm-hmm.
There was a request, Bev, to put that question out as a poll. Is there proof with modern science?
Oh, yeah, that's it. Okay, yeah, I can do that.
Yep. It may beg the question as to what is a proof, or can a proof exist at all? Can a proof for anything exist? in reality. Science.
Oh,
That's
yeah,
science. No. You can have proof in geometry. In rules you make, you can have.
But
like-
outside of science, you can have proofs?
For sure.
Just not in science.
But wait a second. Geometry is science or not? Taiki, geometry is science or it is not a science?
I don't think Chike understands English, Paper.
Oh, he's been waiting for you, Paper. Jakey, this is Paper. He's here. He's asking you a question. Can you hear him?
Paper.
You've not got him blocked, have you?
No.
No.
Taiki, I have a question. Is geometry science or it is not?
No,
science?
it's not geometry.
Geometry is not a science?
Not how we call it.
What about modern geometry? Have
Not a
they
science.
not modern science
It's maybe called
geometry?
science, but it's not what we're talking about. It's not reality.
Well, what have you done, Jakey? Turn your voice thing down again. Have you got a vape thing?
I stuffed my face. I had to stuff my
Oh.
face.
No, I think there's not many vapes
Nature
so
science,
far, but
nature
it definitely
science,
seems
how
to
you
be
call
in the
them?
favor of no.
There's no proof. When you make the rules, you can make any proof you want. It's your rules.
What? You don't just
When you
make
make the rules.
proofs, Jakey, do you?
Huh?
Or is that modern science?
You ever listen to what I say?
Go on,
Say
say it
when you
again.
make the rules, not nature, you can make any proof you want. When nature didn't agree on anything with you, you can't make proofs. Why? Because you don't know what the rules of nature are.
Okay, so are there proofs within reality?
No, none. Zero.
Is that because that's modern science?
That's because it's reality.
So where do you think proofs
We didn't
exist,
make the
then?
rules of how reality looks like. We can try to describe it. We didn't make the rules. This will work like this. If you hang the plum, it will go this way. We didn't make this rule. It just does.
Yeah, vertical. But do
We
you
decided
not
to call it
think that
vertical.
there's
We
a proof?
decided to call it vertical.
Yeah, have you? Well, whatever it is, do you not think that there is a proof that a plumb bob
proof of what?
hangs vertically?
No, there is no proof. We defined it. We say plumb bob. This we call vertical. It's not vertical because it hangs vertical. It's because we decided to call this vertical.
No, it's a straight line.
It's
right?
a straight line.
But it gets labeled. It gets labeled.
Hold on.
Vertical.
A straight line is vertical. Every straight line is vertical.
No.
So why you say this one is vertical and the other is
Because
not?
vertical, it's called vertical. It makes it different from all of the other straight lines.
How
that are
is it
not
different? It's
vertical.
straight as all the other straight lines.
Yes. Yes, but
Yes,
vertical has a difference, doesn't it? It's like a straight line.
No, it's a
yet
straight line.
It has an orientation.
Really? What is its orientation?
Vertical.
Vertical means down.
What do you
Up,
mean
up
vertical?
and-
You can't
up
define
and
it. It's a
down.
straight line. You say its orientation is vertical. It's what I call vertical.
Yes,
Again,
up and down.
you're going around.
Up and down orientation.
What do you mean up and down? What's up and what's down?
Up,
How do you find up?
Up to the sky, down
The
to the
sky.
earth.
So sky is up.
Sky is up, earth is down. Yes.
Really? And when you look to the horizon, straight ahead, do you see the sky? Is that
Yes.
up? Is that up or down?
Slightly up.
You know you will fail on this every single time. You can't define what's up and what's down. You can't define what vertical is because
Yes, we can.
we define vertical as a plumb. Plumb is vertical. That's how we call it.
Yeah, that's the definition then.
Yes, it's a definition. So we defined it. It's not vertical because it's vertical. It's because we chose what it is to be vertical.
Yes, up and down.
Simple
Opposite
English, really
opposite
every kid
vectors.
can understand.
Opposite vectors. So we have two vectors.
No, up and down, you call what plumb is.
Yeah.
This side where things go the opposite way is down, and those that don't go up is up. Then the opposite is up. That's what you call it because of the plumb.
Yeah, because it is opposite. The true opposition.
But that's how we define it. No,
No,
it's not how it is.
We
it's
can
how
observe.
we define it.
No, we observe it.
Observe? No, we don't observe it. We agreed. You can't say the sky because the sky is also ahead of you, not only above you.
Of course, but if we
so
are talking
so
about,
of course, so the sky is not up and the plumb is not up. You can define what up is. We call plumb vertical. End of story.
We can.
It's waste of time to talk about it.
We can, because it is
Go
opposition.
ahead, do it.
Opposition is in different direction. So it is if you may say that it is 180-degree opposition. So if we have down like plumb bob, so if we take 180-degree, so that would be up, and this 180-degree is straight line.
I don't understand the part of the plumb that mostly points not to the sky. You call down.
Yes, this is to the earth. Yes, and if we can take
the earth. Wait. The plumb has anything to do with the earth? You want to tell me that the plumb has anything to do anything to do with the earth?
Chaiki, if we have this plumb bob and we turn 180-degree, then we have up. This is complete opposition in straight line.
So you define up by the plumb, not plumb by the up. Again, you're circling. You have a plumb that is vertical. We call it vertical. One side is up and one side is down. That's how we define it. It's not that the plumb is plumb because one side is up and one side is down.
Yes, in straight line. Yes, 180 degrees. That's why we call it up and down.
Do you want to?
Well, now can I see the proof that plumb is perpendicular to horizontal?
Chaiki, we're going to go over a perpendicular argument now. Would you like paper to run you through Beddy's perpendicular argument to see whether you can understand the flow of how a modus ponens is built from a master, Beddy, the proofless dogmatician? One of yours is vying to be a shadow giant. Now, you can get a bit part if you want in this, because this is a team effort. Can you see that paper in the live chat?
Yeah.
Do you want to have a go and see whether you can explain that argument as simply as possible to Chaiki, please? Just the argument. Forget about Chaiki. Forget about all of the labels. We're going to just go with the geometric principles and the reasoning behind this. Are you all right with paper explaining it to you? Is that a yes?
Okay, Chaiki. A is perpendicular to B. Yeah. Do you understand that statement? In that way, as I understand, that A is straight line.
Hold on, Pepper. I need to raise your voice. I can't hear it.
You are all right now?
The question is, how do I do it on this app? Okay, I try to listen.
You can do it in the Discord. You can click
I'm trying.
on me
Does it work?
and set volume higher than it is. This volume bar. If you are listening on Discord, because I don't know if you are listening at on YouTube, then it is worse. But directly you can change my volume in voice chat. Just clicking on my icon and moving bar from lower to higher.
Yeah, I'm trying.
Always tricky, this sort of stuff, is it? Is it the argument, Chaiki, or is it just the volume that you can't hear? I can hear paper okay.
No, just paper is a bit low.
Okay, can we agree that in first sentence we have A is perpendicular to B, and of course A is straight line and B is straight line. Can we agree on that?
Go on.
Okay, so I guess it is a yes. So two lines perpendicular to the same line are parallel to each other. So if A is perpendicular to B and some other line, let's say C, is perpendicular to B, it means that A and C are parallel to each other. Do you agree with that?
Mm-hmm.
This is simple axiomatic statement but it is replaced by C in that description, but it doesn't matter. So this is axiom. So if you agree, then we can say that if we can replace this A with vertical and B with horizontal. If vertical is perpendicular to horizontal and another vertical is perpendicular to horizontal, to the same horizontal, it means that these two verticals are parallel to each other. Do you agree?
Wrong, no, because you
See, you
assume
use the wrong way.
horizontal,
Just do it the other way round. Do
you assume
horizontals
that horizontal
perpendicular
and
to the
straight
vertical.
line. You're assuming here a bad assumption.
Vertical are straight lines. Yes, they are.
Yeah, it takes you weeks to go over it, and in 2 seconds I find the flow.
Okay, what about then if we have two perpendicular horizontals to one vertical?
You don't.
In this logic.
You don't.
Well, horizontal perpendicular to vertical?
To a vertical, yeah.
Okay, right. So that first part affirmed.
Nothing was affirmed.
Well, if A is perpendicular to B, and you sort of affirmed
I said
the
horizontal
fact that vertical
is perpendicular to a vertical.
Okay.
Vertical. A vertical.
Okay,
not
right.
vertical.
So okay, well that works. So if two horizontals are perpendicular to the same vertical, then they will be parallel.
Mm-hmm.
So the logic works.
Yeah, only the you can't find them. It's a big if.
Yeah. Well, it's perpendicular though, right? So it does
you
work.
live in an if world.
Yeah. Yeah, but that's what Beddy's logic
But our
is.
world is not an if world, it's a real world.
But this is Beddy's logic. Betty's
No,
perpendicular
it's
logic.
your logic. It's your flawed
It's not
logic.
my logic. It's Betty's.
Betty's logic is fine. Your assumptions are bad.
What assumptions?
That horizontal is a plane
Perpendicular to
or straight
horizontal.
line. Is a plane or a straight line.
Yeah, perpendicular to horizontal.
You assume horizontal is a plane or a straight line.
No. We like what we said.
It isn't.
For Betty's,
It isn't.
Chikey, for Betty's argument, it's just perpendicular. So is vertical perpendicular to horizontal?
But your horizontal is not a line.
Okay, let's try another one.
It
North
doesn't
south.
matter how many times by
North
answer will be the
south,
same.
east west.
You will fail.
North south, east west. Are they perpendicular to each other?
At the point of intersection, yeah.
Okay, so two lines of east west. Two lines of north south. If they were perpendicular to the east west, would they be parallel to each other?
No, they won't.
No, but they are perpendicular.
At the point of intersection, yeah.
Okay. So this is the problem that we seem to have got, or the one that Betty's got.
No, Betty had got no problems, I'm sure. I can't speak for his problems. But
Betty says that
Betty's side rule?
if these two lines are perpendicular to each other,
longitudes are not lines.
Nobody's put longitude.
You forget they are curved.
Oh, so you've got
but
longitude and latitude, are they perpendicular to each other?
Well, according to whoever says that curved lines can have angles, then yes.
Okay. And what about plumb and level? Are they perpendicular to each other?
Depends.
Okay. Now, of all of those, there's four there, isn't there? Horizontal, vertical, plumb and level, north, south, east, west, and longitude and latitude. There's four different things that are perpendicular to each other. Can you think of any others?
No, one longitude.
What about two tangents at the end of a diameter?
One latitude, but not another one.
What about two tangents at the end of the same diameter?
Two tangents? What?
Two tangents at each end of a diameter.
Yeah, what about them?
Are they perpendicular?
To the diameter? Yeah.
Okay, right now. Of five things there we've got then. Can you think of any others? It's hard work, isn't it?
It's not enough. It's not enough for you.
I'm just trying to think of as many as we can possible. If anybody else has got any,
if something
in the YouTube chat can think of any of other things that are perpendicular to each other that we can add into Betty's logic to check Betty's logic out. So let's start off with the geometric. Are the tangents perpendicular to the diameter?
Absolutely.
Okay. Now, if they're both perpendicular to the same line, then they will be parallel to each other. So are the tangents parallel to each other?
Mm-hmm.
Okay. So that works. So Betty's logic is good for perpendiculars involving geometric lines that are perpendicular to each other. So it works.
Yep. If the framework is the geometry, then he's absolutely right.
Yeah, well, that's what he's done. He's wrote it as two lines perpendicular. So where'd you get the definition of perpendicular? Euclid's Elements. It's right in there. Perpendicular. Foundations of Mathematics. And
I
parallel.
love Euclid. I love him.
Where's parallel? Where'd you get the definition of parallel from?
Euclid?
Absolutely. It's in definition 35. So definition 10 and definition 35, book 1, Euclidean geometry, Euclid's Elements. So, and then it says, chorally, because parallel lines by definition do not meet, lines of whichever do not converge.
Parallel. Yeah.
Yeah. Okay, so what else have we got that's perpendicular? Well, we'll put some more of these things under scrutiny of Bede's perpendicular argument. Which ones do you want to go with next? What about north, south, east and west? Because I do have a thing about that. Let me see if I can find that. All albums. While you've been away, we've done a few arguments, Jakey.
So far, I haven't seen an argument.
You haven't seen an argument. Anyway, check this one.
So far.
We call this one
you failed every time. You made bad assumptions.
Thank you very much. Sorry, gang. We call this one a cog diss check. You're all right? Are you okay with your cognitive dissonance?
Yes, you refuse to admit that you made bad assumptions. You never checked.
Okay. Well, this is 2 questions. Question 1. Do you imagine the cardinal directions of north, south, east and west are lines at right angles to each other, i.e. perpendicular?
No.
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 Okay. Can I ask you why?
Because we live on a sphere.
And you don't imagine that they can be what?
And I think that direction we're talking about related to the place we live on. The place we live on does have effect on them.
Okay. So you wouldn't say that north, south, east and west are perpendicular then? Or would you? Because if they don't fit the bill for perpendicularity, then it's not really much use putting them in the perpendicular argument to check, is it?
Like I said, Euclid in book 3 says you can have angles to curved lines.
No, we're talking about book 1, the definitions.
Well, I don't care what book you talk about. I take care about what Euclid says.
Okay. So are they perpendicular then, or are they not perpendicular?
Yes, they are.
Okay, so they are perpendicular. And how many of the 2 straight lines do you imagine are circles? That being north, south, east and west.
Straight line is not a circle.
Okay. But perpendicular is 2 straight lines. So, are they perpendicular?
Who? What?
North, south, east and west.
Yes, yeah.
They are perpendicular. How many of them do you imagine are circles?
All of them?
Both of them.
All of them.
All of them. Okay. Do you want me to go? I'll go through these ones just to try and do this. So you've got two circles perpendicular to each other. Yeah? You're okay with that? Now what about what about that? Do you believe or can you imagine a place where the only direction is south?
Mm-hmm.
Where there's no east and west, just disappears.
Yep.
And you can imagine that.
I know where it is.
Oh, you've got a location for it.
Yeah, I have a name for it.
Monad?
No, it's called North.
North. Like a place.
Place, yes. North. Here. This is south, this south, this south, and this south.
Okay, what
North,
about this?
no,
Then?
east and west.
Do you believe there's a place where the only direction you can walk is north?
Mm-hmm. That's called south.
That's called south.
Yep.
Brilliant. Now, this is the cog-dis part.
Who's cooked this?
Well, I don't know. We'll see. See whether you can see. Check that out. Can you see the contradiction?
Oh, wow. Can you see that the contradiction? That's cooked this.
No,
So
I'm
can
saying,
you see the contradiction?
Can you
Can
see?
you see a contradiction in what I
Yes.
said? Yes, show me.
No, in the picture.
Walk me
I
through
know,
my
put your
contradiction.
glasses on, Shaky. Can you see?
Yeah. Yeah.
Can you see the contradiction?
In the picture.
No, I can't see it. I can't see the contradiction at all.
Okay.
In this
The
picture.
contradiction is that that you drew the image, because you think that the southeast, northeast, west, and south are straight lines.
Yeah, you've got
You
two.
made
You've
a
got 2
bet.
points.
You made mistake every fucking time, and on that,
This is why I said
you
about
say
your
I'm
cog-dis. You're
saying a
not okay
contradiction.
with cog-dis, are you?
Contradiction. I have contradictions because you drew straight lines.
No, I'm just going to point out to you now. In that picture, you can
Well,
see.
no,
You can see there's 2 points, right? And every direction from one of the points is the other point.
Those are circles.
You've only got 2 points.
Those are circles, Bev, and you drew straight lines.
No, you've got a point where every direction is south.
I don't care about the point.
Where
The
every
line,
direction is north.
the line is curved.
What line's
You
curved?
drew straight line. South north is curved.
Yeah, I mean that's irrelevant, isn't it? You've got every direction.
No, irrelevant, really. We
But-
talk about it and
yeah.
it's irrelevant, and you say I have a contradiction.
Yeah, I think
Bev,
if you don't see it,
you're
then
not
that's okay.
you're not thinking straight. I see your error.
No, there is no error.
No, that's
Jakey.
the cog-dis. Now we
No,
found
your cog-dis
cog-dis.
is you telling
No,
me there's an error. I'm not
I
saying there's
didn't
anything
make
wrong
an
with it.
error.
A lot of people
I
think
didn't-
that like that, Jakey. Don't worry about it.
I didn't make an error. That's a cog-dis.
Nobody said you did.
So no, you say I didn't make an error. That's a cog-dis. You fell in it.
No, I
Your
was saying,
cog-dis,
can
not
you
mine,
see a contradiction?
Yes. I
So
see
you can see
contradiction.
the contradiction.
You,
Good.
you take one thing and you make it another, and you say I didn't make an error. That's
No, I
the
was just
contradiction.
saying, it's a question. Can you see the contradiction? You said
There
you
is
couldn't.
no contradiction.
Well, there is no contradiction.
Here,
Mhm.
contradiction in your image?
In the image, yes. Can you see contradiction in this picture?
I don't know. Well, I have north, north, south. What's the contradiction here?
Contradiction here is that you have on the left one, you have north in every direction, and on the second, on the right one, you have south in every direction. And this is
where's the contradiction here?
This is contradiction because you cannot.
Where is the contradiction here?
Because you have in the same. It means that if you have north in every direction.
Do you have anything close to a sphere near you, Pepper?
No. I am talking
draw a point on the sphere. Call it A.
No. We are not talking about sphere.
Call it B. That is antipodal to the point A, and tell me if you can, if in any direction you have anything else.
What's the shortest distance between other than 2 points?
Cog this, Bev.
I'm just asking Paper. Paper, can you just remind us what's the shortest distance between 2 points?
Straight line.
Okay.
That lies evenly between extremities.
Does that have a vector?
These lines have vector, yes. Vectors.
Yeah, from north to south and from south to north with one line, right? 2 points.
Have you checked it?
Hey.
Have you ever went from south to north in a straight line and got to where you thought you would get to?
Geometrically, Chaiki, you've got 2 points.
I don't care if we don't believe in geometry, we live on Earth. Have you ever went south in straight line?
How do you think
and got where you thought you were going to get to?
It's all right. Don't worry about it.
You will end up in space every single time.
That's why I call it the cog disc check, because everybody reacts differently, and they always will.
So we saw the cog disc. Everyone saw the cog disc. You are all cog discs.
Can I show my cog disc?
Go right ahead.
Okay. All of this talk of direction, how do you know what direction you're traveling in the first place?
Me?
With a compass, right?
Ways.
Like the only way we know what direction we're moving is we would have to have some sort of device, right, to tell us that we're going in that direction, or do we just walk aimlessly in a straight line somehow?
Yeah, just go over to the tree, turn right, head to the lake. I mean, what are you talking about? Direction?
I don't know.
This is all about imagined relationships of cardinal directions. Yeah, that's all we're doing. It's just a mind.
Yeah, but how do we determine what direction we're traveling? I
don't know. We look at the star.
You look at a star and you know what direction you're going?
Okay, there's about 4 different norths, right?
Well, I only know of one north, and I can only know which way is north by looking at a compass.
No, you've got east-west, haven't you? You've got perpendicular to east-west.
Yeah, but how do I know
the rise and set of the sun? It rises in the east, sets in the west.
How do I know? Yep. How do I know that the sun is traveling in a straight line or a circle?
Well, I'm saying that, yeah.
That's my cognition.
That's simple. You assume it's a straight line.
If you've got 2 points, geometrically, you relate it to a straight line, don't you?
The Pac-Man F, right? It goes in a straight line from you away and then come from you back. That's a straight line for you.
No, I think that's what you call an orbit.
Orbit?
Yeah.
You mean a curve, like?
No. An orbit's a straight line that returns back on itself.
Show me the definition.
It sounds ridiculous, doesn't it? Yeah, I know.
Yeah, it sounds ridiculous because you just made it up. First time in history.
It's called great circle.
Wait, you said circle. No, Bev's talking about straight line.
Great circle.
You're going to be punished, Pepper. You talked without
What?
permission, right, Bev?
I don't know what Chokey's doing. I think
Yeah,
he's
you're talking about straight line. You say orbit is a straight line, and
it
Pepper
returns
said it's a
back on
circle.
itself. Yes.
It said it's a circle.
Yeah.
A straight line.
Great circle. He called
definition.
it. Do you not have a concept of a great circle, Chokey? I mean, you've got rid of the contradiction of the 2 points being a straight line already, because you've got both of the 2 points. Every point goes back to the other point. Most people would imagine north being one place and south being at the other, and they're a straight line. But you've got a concept of north. Every direction from north takes you to south. Every direction.
Is there any other possibility?
Well, that's not really a possibility. It's a bit of a contradiction.
No. Can you go from north anywhere but south?
This is the whole idea of the
I want you to show me how you walk
on
from
north, south, east, and west. The
I
cardinal
want to show
directions
you to show me
perpendicular
how
to
are
each
you
other.
east from north.
We're trying to give you a concept of Bedy's perpendicular.
Yeah,
logic.
think about the concept. I want to see practically how I walk east from north.
Perpendicular, is it? Is east perpendicular to north?
No, not at north.
Oh. So
there's no east at north.
Oh, so east is gone.
Gone. Vanished.
Okay, so you can make east and west disappear and every direction turn
Yeah,
into
just
south.
by being at north. You want east, you need to move away from north.
Have you ever done that?
No.
No. So it's just an imagining then?
Not an imagining, it's a fact.
Well, it does seem like a very contradictory fact.
It's provable with a plastic ball on your table.
Sorry?
You wouldn't be able to draw east from north on a ball on your table. Not possible.
Did you just say provable?
Any perpendicular will be
not
south.
provable. No proofs in reality, right? So
It's
what are you
not
talking
science,
about?
this. Yeah.
Oh, as long as it's not science. This is not science. Okay, got it.
I had Bev says he's going with modus ponens today. He'll prove the positive.
It's Bedy's perpendicular argument. What you do is you prove that if these two lines are perpendicular, then one of, or each, it doesn't matter which one, will be parallel to each other. The similar lines, both perpendicular to the same line, will be parallel to each other. Now that's Bedy's perpendicular argument. But I think what you're here today to show us is the fact that you can have contradictory evidence. You can say that, well, yes, they are perpendicular, but no, they're not parallel.
What?
Would that be sort of where we're going? Because this is the problem that I've been talking to Bedy
about. Because I'm not narrow-minded like you.
Narrow-minded.
And not everything, yes. Because I don't live in the world where everything is a surface, a plane or a straight line.
We're just talking about Bedy's perpendicular logic, though.
Well, they work only on planes and straight lines.
Yeah, a perpendicular is a plane rectilinear angle.
Well, yeah. So, but we don't live in this world.
Actually,
this is not the world we live in.
Parallel also. Within the same plane.
Bedy's argument is very simple geometry.
Yeah.
And you try to extrapolate to reality.
No, Bedy brought it to us, so we can discuss it. We that's what we do here. We discuss these issues. It's Free for All Friday.
Okay, we discussed it.
Yeah. So, what we're going to go over is the fact that if you can have a logical statement about perpendicularity that works, but there's certain modern words, or I think modern science has attached words that undo that logical statement, the logical argument that has been proved within geometric principles. And we're going to break that. And hopefully you're here to help us know how this break occurs. It's more like a bit of an explosion, I'd say, but...
I already told you, you make bad assumptions.
Well...
It's not going to change. It doesn't matter what you're going to show. The bad assumption stays there.
Have you ever done any logic at all, Chike?
Yeah, I showed you logic in our debate.
Okay, so do you know what a syllogism is? Because I believe
no, I don't
this
fucking
can
care
be
what
placed
syllogism. I know what I know logic.
And,
no,
and
I
then
don't
we
know.
can show you
I know.
the antecedent
I don't care for words, Pep.
and the consequent.
I don't
we can
care
get
for
rid
words.
of the middle term.
I don't care for your words, Bev. I know what logic is.
Did you say?
Yeah, words. I'm software engineer. I lived in logic. Don't tell me what logic is.
Okay. All right. So you do understand what a syllogism is then? And going back to the diameter and the tangents, we can say that if two straight lines are perpendicular to the same line, then they will be parallel to each other. Right? Because we both understand the meaning of perpendicular and the meaning of parallel. So we can use this to check whether things are perpendicular to each other. Because it's a logical statement, right? Either modus ponens or modus tollens.
You don't test something by logic. You measure it.
What?
You don't test something by logic. The logic defines, like I said, defines.
But the logic works, doesn't it?
That's a framework, the logic. If you want to test it, what you say in logic applies to reality, you need to measure it.
Okay. Right. So can we measure vertical and horizontal being perpendicular?
Yeah, to a certain
Absolutely,
degree of
yes. I would agree. Anybody else?
accuracy.
Can we measure in reality vertical and horizontal being perpendicular?
We can and we do.
There you go. Provable every day by just about every workman that ever does anything during the daytime. Right? So that can be proved, right? What else? North, south,
I don't know.
east, west.
I don't care about can. Again,
they
you come
be
with can. I want
as
to
being
see the
perpendicular?
proof. I want to see the measurement, Bev.
The measurements of a right angle, they're all equal. Jacob.
Yes, I want to see the measurement of the right angle between perpendicular, between the plumb and the horizontal.
You're a little bit shaky.
Go ahead. I want to see. Show me the numbers.
The numbers.
That you measure. Yes.
There is no number for a right angle, Chaiki. There's within geometry.
Yes, there is. It's called 90 degrees today.
It's called a right angle. No, you might call it 90. It's the right angle.
So how do you know it's the right angle? How do you know it's the right angle?
Because they're all equal. There's 4 of them.
So you measure them to be. You need to measure them to be equal.
Perpendicular.
Yeah.
So go ahead. I want to see the measurement.
Perpendicular is the
angle.
proof.
I want to see the measurement. The plumb angles, both sides to the horizontal, are equal to each other. Show me.
Show you? Are you serious?
You will not show me, babe, because you haven't done it. You will not do it because you live in Cogdis.
No, you can do that. You can have, for example,
Pepper, again, I don't care what you can do. I want to see you. I want to see the measurement.
Just keep a lid on your Cogdis for a moment, right? Don't get upset,
you're afraid
right?
of Cogdis now, huh?
Yeah, you do.
Me, no. You throw a stone that is coming back at you.
Sorry.
Okay.
Like a boomerang.
I can say only.
I don't care about
Okay.
Ken. Ken doesn't prove anything.
It doesn't matter.
Okay.
It doesn't matter.
Ken prove things.
Jakey,
Pepper.
Jakey, check him. Check that right now.
On the screen.
Check it on the screen.
On live chat.
Find the difference. There's 3 plumb bobs there, and there's 1 water level and spirit level, and a line that I've drawn. Take your pick. Use any of them. Find out if one of them's bigger than the other. You know.
So you have level and plumb, and you can extend this plumb bob down, and you can measure that these 4 angles are equal to each other.
To what accuracy?
Yep.
To what accuracy? What accuracy of a degree are you measuring?
They're equal.
I thought.
You tell us what accuracy do you think you could measure?
You know accuracy is.
Off you go.
Do you understand accuracy?
Yeah. Tell us. You tell us.
So how many
Chaiki.
degrees on the right side and how many degrees on the left side?
Chaiki, you check it and you tell us how accurate.
So no, the proof is on you, not on me. You claim they are equal.
You asked me to show you.
No, tell me, show me. No, they are not equal. Don't look equal to me.
They don't look equal to you.
No, you will need a measurement tool now.
Which way
tell me the numbers.
Which way would you say that the vertical's tilting or the horizontal's tilting? Which one?
Both.
Both. But they could still be perpendicular then.
No. They can't be.
They can't be perpendicular.
You don't do the measurement. You show me a picture that its resolution is at best, I don't know, let's say 1/10 of a millimeter, and you'll tell me they're equal.
Yeah, they are.
They are
right
not.
angles.
They are not. No, they are not equal at all.
Okay, so which one is going to be bigger? The one on the right or the one on the left?
I haven't level. I don't know how much level this level is. What its accuracy. Everything matters. You didn't make the measurement. Show me a picture. Tell me you did measurements. You kidding me?
It's perpendicular, Chaiki. Do you not believe that vertical and horizontal are perpendicular? Or plumb and level? Do you not believe that they're perpendicular? I mean, which one?
Bev, let's lose the word believe. I don't believe. I know or I don't.
Okay. Do you know that vertical and horizontal are perpendicular?
That depends. It's a loaded question.
This is just simple question.
No, it's not simple question.
It's about your
question
knowledge.
You struggle for years now, Pepper.
No,
horizontal.
Question. Do you know
horizontal,
that they are? Do you know that they
horizontal is perpendicular to a vertical.
Okay, so we know that. We know that, right? What about plumb and level? Are they perpendicular? Are they perpendicular like vertical and horizontal are perpendicular?
A plumb is perpendicular to level at some point.
At some point?
Okay.
Yes.
Okay, so is on this picture, is this plumb bob is perpendicular to this level?
How would I know?
The center one. Just concentrate on the one in the center.
I don't know. I didn't level it. I don't know its accuracy. How would I know?
The water level. Can you see the water level?
You assume that this level is level.
Yeah.
And it's accurate enough for you to know how level it is.
Can you see the water
and that it's
level?
Perpendicular
Chaiki?
to some of the plumbs.
Because you don't need to level the water level, do you? Can you see the water level?
What do you mean you don't need?
two ends of water level on the sides.
Yeah.
Yes.
Okay,
And
so that's
they
the water
have-
level.
And this water has height, and this height is equal. So you can
Okay.
you can imagine straight line between two
Actually,
ends.
the height may not be equal. It may depend on the air pressure. There are
No,
many factors here.
The air
You
pressure.
haven't checked. It's not an isolated experiment. If
It
you have
is.
wind on one side
One end,
and you
one
don't
end
have
at
wind
home.
on left side, for example, a fan, you may raise the water may be raised or lowered
It's
on
not,
one side.
Jakey, it
nothing
is
to
at
do
home.
with cognis at all, this, Jakey. Is that?
Cook
Jakey,
this,
it is-
huh?
it is
You
at
ignore the
home.
fact that when you do an experiment, you need to do it right.
Yes, it is at home. There is no.
Yeah, no wind at home. Really,
No,
I have
home.
wind right here where I
It's
am.
not that
I
windy
have a
in
good breeze.
my room. Yeah.
Mikey,
By the way, water level is used outdoor
You have
also.
computer fans. Sorry, those push air.
What? The
You didn't know
pressure-
that those things that make noise push air?
the pressure change of the computer fans that alter the level of the water.
Yeah, airflow is a change in pressure.
Yeah. Okay, so is that your rebuttal?
Can one end of the water level
I don't
be
need a
lower
rebuttal
than the
for
other?
your silly
Could you ask-
pseudo arguments.
Can one end of the water level be lower or higher than the other end?
For sure. You haven't attempted to test anything that you say. Anything. Oh, plastic tubes. I'm impressed.
Yeah.
Mm-hmm. And they are rolled.
Do you like that? Water level scale perspective. The bigger one is 100 meters and the smaller one is 400 meters. Why would somebody possibly have a 400 meter water level, Jakey?
I wonder why when you have a canal there and you don't need the tube.
Might it be for testing for horizontal?
Well, you test if water in tube act like the water in the canal.
It's a water level, Jakey.
It's water, it's still water. So you say maybe water in the canal behave differently than the water in the plastic, which you probably do.
Do you think it does? You should
I don't
do
know.
a
Have
test
you
for
checked?
yourself.
Have you checked to see? Have you checked to see that?
No, it's irrelevant to
those
what our
tubes-
test was, Jakey, so don't worry about it.
Well,
We're
you
talking
didn't do
about-
any test.
We're talking about Betty's perpendicular argument.
Well, I thought we over it.
But it's obvious already, Chaiki. You're letting everybody know the problems involved with a very simple perpendicular argument that Betty's come. Now, can you imagine why Betty would have brought that argument? If it causes,
Like I said,
if it causes you and people like Flat Earth Mathematics problems,
like I
sorry,
said,
I mean Flat Earth Charles. If it causes you and him problems, Chaiki.
Like I said, anything you have to ask Betty, don't ask me.
I'm not asking you.
Yes, you do.
Well, I was
You just
asking
did.
you, can you
Fuck
think
this.
of any reason why Betty would have brought that argument?
I don't know in what circumstances he brought his argument, when he brought his argument, and who he brought it to.
Okay.
I have no data to work with.
Have you not? Okay. Well,
Nah,
let's
no,
go
like
over
I
it
said,
then.
I came here without telling anyone.
Let me get.
Betty didn't approve that I come here. I'll probably be slept.
Betty didn't approve. Like you don't.
No one did.
You don't have to answer
No
to
one did.
Betty, do you? You don't. Really? Betty's Betty. Has anyone seen Betty in the chat? No. Okay, let me. Oh, look at that. It's transition. You guys want the
Well, if you unban me, I would be able to see if Betty write in Blue Marble Service server. But since you didn't, and this account is not joined there, I can't see what it says if it does say anything.
Right, can you see that? Is that all right for you guys? Is that working a bit better? I'll give the output. Hopefully it should be a bit of a better screen. Can you see it?
I can see, but this is too low resolution. I cannot read text.
It's not readable, is it not? It was all right the other day, wasn't it?
What we looking at now? Where?
I can give you the is that any better?
Slightly, but still.
Let me see whether
time
I can,
to read that.
Yeah, let me see whether giving you the other window's better. Is that better?
Now it is.
Okay. We had it sorted the other day so you could see the actual screen that everybody else can see. Right, so Shaky, can you see that now? I'm displaying it live in Discord. If you come into Discord, they'll be able to see, but they can just see the screen that YouTube can see, so don't worry about it. These are the comments of, well, 3 days ago we did a Model Affliction Monday. Beddy's done a comment on it. And he says, premise 1, any two lines of longitude are perpendicular to a line of latitude. What do you reckon, Jakey? Do you go along with that?
Yeah, I'll go with it.
Okay, he says, premise 2, any two lines perpendicular to a third line are parallel to each other. He's basically got that from Euclid. There's a better Euclidean proof that you can place there, but that's like it may sound like an assumption, but it's got geometric backing, that statement.
Okay.
Conclusion, any two lines of longitude are parallel to each other. That's a brave move, isn't it? That's Beddy's perpendicular argument. He says the argument is perfectly valid, brackets, meaning the conclusion cannot be false if the premises are true.
What are the premises?
The 1 and 2. Any two lines of longitude are perpendicular to a line of latitude.
Yeah, but longitude are not lines.
So you are falsifying first premise.
Yeah.
Okay.
Yeah, I mean, that's okay, right? That's fine. So you're not going along with the first premise. Because he's saying, meaning the proof. He said, let there to be two lines of longitude. Longitude 1 and longitude 2. Then by premise 1, there exists a line of latitude such that both longitude 1 and longitude 2 are both perpendicular to latitude. By premise 2, it follows that longitude 1 and longitude 2 are parallel to each other, but longitude 1 and longitude 2 were any two lines of longitude chosen at random. Therefore, the conclusion must be true. And since it is impossible for the conclusion to be false when the premises are true, it follows by definition that the argument is valid, QED. He says, the argument is valid, but is it sound? A sound argument is valid argument with true premises. if the conclusion is false, it means that one of the premises is false.
So it's cluing that I was right. That the premises were not true.
Well, that's what he's saying. He's saying if the conclusion's false, then you have to falsify your premise. It's
Which
like a
is
modus
false.
tonans. You go, if not Q, therefore not P. Right? You've heard.
Well, the
You've
premises
heard
are
that?
false.
Yeah, that's a modus ponens.
If we were going by Euclid, this was perfectly valid and sound. But
Well, it depends
we
what
don't.
you put there, doesn't it?
Well, we put a line. It's
Yeah,
not
you
a
put
line.
lines.
Curve.
If we put diameter and tangent, like we said before, perfectly valid. Straight lines.
Yep. Yeah. Absolutely.
And then I say, let's say, example 1. Let's say someone believes that the initial statement about perpendicular lines to be true, i.e. vertical, horizontal, plumb, level, north, south, east, west, and as you example, latitude and longitude, for instance. The conclusion, as you say, is that the lines will be parallel. But Charles, your mate, Flat Earth Charles, wishes to affirm the perpendicular, but deny the consequent, brackets, the conclusion. He also states that you believe the same. This would mean that both you and Charles are trapped within a contradiction, both within your argument and within the terms. Can you clarify your position with your argument, please? So I asked him right at the very beginning. It's going to go a long way in 91 comments, this. And anyone, please join in, because this is going to be interesting. This is going to be a long time conversation. With that.
I could end it 5 minutes ago.
Pardon?
You just insist to continue.
Sorry?
We could end this half an hour ago. You insist to continue.
So, because,
you insist to continue. You make bad assumptions, bad premises. You get bad results.
I'm going to show you an Aporema, Chaiki, how a magic trick's been performed. You'll like this. You might learn a little bit of logic as well in it.
Okay.
Okay, so Betty set up an argument, and I've put up a possible flaw that somebody might not want to, just like you got rid of the premise. But what about if somebody wants to keep?
No, Betty got rid of the premise himself.
No, he didn't.
Yes, he did.
You did. Because
no, he didn't. He did. He said in the end that the premise is wrong.
No, he didn't. He said if. Well, he says the argument is valid, but he asked the question: is it sound? A sound argument is a valid argument with true premises. If
true premises mean those premises are not true.
If the conclusion is false, it means that one of the premises is false.
Yes, this is
you go.
Yes,
Betty says the premises are wrong. At least one of them.
No, he said that
they just did.
No, he said that if the conclusion is false, it means that one of premises, at least one of premises, is false. But he didn't say.
And the conclusion is false.
Yes, but he didn't say that in his example it is premises are false. He didn't say that.
It's just laying out an argument. Don't worry about it, Jakey. It's just a perpendicular argument.
Well, bring Betty in.
You've already said you agreed with the diameter and tangent example. So the logic...
Yeah, no need to repeat it. It's absolutely agreed.
So the logic is valid and sound. It's true.
For the tangent and diameter, yes.
Okay. So Betty replies, affirming the antecedent and denying the consequent are used of conditional propositions, not arguments. Really. This is where he does his sophistry. I don't see how I am trapped within a contradiction. I have simply set out an argument, and I am asking, 1, if it is valid, then 2, if valid, is it sound? Note, as terminology is source of constant confusion in your presentation, that the standard terminology is as follows. This is Beddy telling you how to talk to him. So just in case you ever talking to Beddy, this is what he wants. A proposition is a sentence, brackets, unlike a question or a command, capable of truth and falsity. A proposition is true or false, brackets, don't say valid proposition. So don't say that. That offends him. An argument consists of any number of premises, but usually 2 and 1 conclusion. That's a syllogism. An argument is either valid, equals truth preserving, or not. Please don't say true argument. That upsets him too. If the argument is valid, then it is either sound, bracket, meaning the premises are true, or not sound. If it's valid, it means the truth preserving, but then the premises are true. I don't know why he's adding sound in there. It seems like it's already got it.
For me, if the argument is valid, then it is true.
Yeah.
Because if premises are true, then conclusion is true.
Yeah, if the truth has been preserved, it's true. Yeah. Conditional propositions are in the form if P, then Q. Do not confuse them with arguments, as you frequently do. Anybody can place an argument into a modus ponens, an if P, then Q statement. It's very easily to do. Even when we did the course at the university, the guy said he likes doing that because he's a logician. He likes to rewrite statements into a if P, then Q.
Yes, because if you don't need middle term, you are just creating conditional. If P, then Q, without middle term. And this is argument. This conditional, simple conditional, if P then Q is argument.
He says don't confuse them. A conditional proposition is a proposition and therefore true or false, not valid or invalid. Like he did say valid was true. Valid is truth preserving. And he says it's therefore true or false, not valid or invalid. Well, valid would be true. So why can't you have valid being true like he has valid being true? Seems a bit contradictory, but hey, he makes contradictory things. So just so you don't know where you are with him, I'm guessing. Conditional proposition can therefore be a premise of an argument. Can you stick to the standard terminology, please? So he's laid out the standard terminology. He wants you to stick to that. It's like Beddy's rider. Of course, you are free to make up any terms you like, but then no one trained in classical logic will understand what you're talking about. Classical logic. That's Beddy. And look, it's just, it's great. That's what's great about On the Level here. We're just normal people. Yeah. And we get people telling us how to talk to classical logic teachers.
Look, I have a severe objection here. No one of you is just logical people here.
Well, no, Beddy's teaching us logic. That's what we're doing. Beddy's teaching us classical logic.
You refuse to learn.
Are you with us? We
tell you this is the terminology. Use it. You say no, this is not what it is. Pepper used another one.
No, I said that you can make an argument from P and Q statement. if P then
I
Q.
think he said it too. I think they can
No,
be a
no, he
basis
said
for an
that
argument.
you cannot.
He said it was,
that
yeah, he
P-
said it wasn't an argument. He says
It
conditional
wasn't an argument.
propositions are in
The
the
base
form
for an
if
argument.
P then Q. Do not confuse them with arguments when they are arguments.
Well, and
That's what
after it
papers
says
say.
they can be a continue what it says afterwards.
Right, so I say back to Betty. I understand what you're saying. Perhaps it's me that is not making my question to you clear enough. I'll try and simplify. My question is, how do you answer someone that wants to deny the conclusion but also affirm the first premise? I'd like to hear what you say to yourself, supposing you held that position. What would you say, Chaiki, if you wanted to deny the conclusion, i.e. not parallel, but then also affirm the first premise, like they are perpendicular?
I would call that broken logic.
Do you think that's a clear enough question? Do you think that's me asking Betty clear enough?
Yeah, I don't understand a word you're saying.
You don't understand it either.
Okay, so I will clarify. If we have this argument that if line A is perpendicular to C, and if line B is perpendicular to C, therefore lines A and B are parallel to each other. And flat earth math would deny conclusion but still holding that both of them are perpendicular to this line C. But he will deny that they are parallel to each other, which is conclusion. So that was flat earth.
Conclusion based on what framework?
I have just
said. That's why we're asking you. Like, can you think of any way?
The framework is geometry, Euclidean geometry, then try.
Yes, and
but the framework is not the his framework is not Euclidean geometry, then it isn't right.
So not Euclidean
the premise
geometry,
is right and the conclusion is false.
He's used the words perpendicular and parallel.
Because it's allowed in his framework.
But that's Euclidean, isn't it?
No.
Wait, Chaiki, you've just said that if you have two true premises, you can have false conclusion? You've just said that, I think.
No, I don't. I never said false conclusion and true premises.
You said that this is valid in geometry or whatever, but in real world it is not. So
no, I didn't say real world even. It's enough. It's a spherical geometry, and it's not true. The framework depends. It depends on the framework. He can say they are perpendicular, even they are not straight, and yet they are not parallel because they are not straight.
Okay, but this is not the case. Do you agree that?
How do you know? Bring him in.
Okay. Do you agree that if we have two premises being true, that conclusion has to be true? Do you agree with that?
Again, depend on the framework you work with.
But he is not talking about framework. This is general
rule
of logic.
General, you can't make generalize it. No.
This is general rule of logic.
Well, there are not general rules in logic.
Oh, there are. If they were not, we couldn't use any logic to prove.
Well, there
anything.
may be general rules, but not all of them.
Check this one out then, Betty. Sorry, this is Betty's reply, Chaiki. He says, if the argument is valid, then the premises cannot be true and the conclusion false.
And
Therefore, go on.
You seemingly, Chaiki, deny that you are not. But he is now saying that this is general rule. He's stating that in this post.
Yeah, he's not finished yet.
Thank you. Check your DMs. The Rumpus is trying to help you out.
He says, therefore, if the argument is valid, the conclusion is false, and the premise 1 is true, it follows logically that premise 2 is false. I don't want to interrupt you if you're looking at your Rumpus.
Wait, I just want to say to Rumpus, this is a different account. I asked Bev to unban my other account I can work with. I only have this server on this account. I can't see my DMs. I can't see anything. And you couldn't just do the simplest thing and take me off the ban list.
Yeah, because we don't do that.
So I don't see the Rumpus. I can't see. You like this, and I can't answer or see the Rumpus. I need to log off, and then I won't be able to be here.
Rumpus. Yeah, don't worry about it.
I'm not worried.
I can see the way that you changed there, though. When
I'm just telling the Rumpus, it's a courtesy.
Bring that up. Bring the new Shaky back. Bring him back.
It's a courtesy thing. I'm telling the Rumpus, I simply can't see his DMs.
Okay.
But can you agree? Because this baby statement is very simple and very clear. So if one of your premises... I don't think it's
very clear. To you, it's very clear, not me.
So I would clarify. If one of premises is false, whichever, it doesn't matter. It can be both premises can be false, and then conclusion would be false. And premise 1 could be false and second true, or vice versa. The first premise can be true and second false, and the conclusion would be false. So I think that it is understandable for you. Just one of premises is false, and it falsifies conclusion.
This is the simplest thing to understand, Chaiki. If you don't understand this, you can't move forward in logic.
What about my question back to? What about my question back to Betty? Says, do you really think Flat Earth Charles is attempting to falsify your second premise? Because I knew. I said, does he know you use proposition 28 as your second premise? Because that's a Euclidean proposition. And it's a bold move to want to affirm the antecedent, deny the consequent, and falsify Euclid in order to do that. I mean, that's a bold move, right? You've got to admit that, right, Chaiki?
You're so dramatic.
Well, I mean, I don't know about you. This is Shadow Giant shit, this. This is big
know what's worse
Shadow
than Shadow Giants?
Yeah.
Shadow Midgets. Shadow Dwarves. You stand in the shade of.
We're talking
people
about,
without name that
Betty,
nobody knows.
We're talking about Betty and Flat Earth Charles here.
At least the Shadow Giants. Not Shadow Dwarves or
I said they're making a bold move to become Shadow Giants. Chaiki.
Okay. You and your nonsense.
Well, that's what he said. Like Betty says it here. If the conclusion is false and the premise 1 is true, which is what Charles wants, it follows logically that premise 2 is false. Premise 2 was his Euclidean proposition 28.
I don't know proposition 28.
I know you don't. Don't worry about it. It's only Euclidean. He says, I don't know what Charles is attempting, but it seems you agree with my logic. If the argument is valid and the conclusion false, one of the premises is false. Therefore, if premise 1 is true, premise 2, brackets, proposition 28, is false. I'm glad we agree. It says, however, there is a hidden premise which I have spelled out. Perhaps you can spot it. Is there a missing premise? The argument is not. If there is a missing premise, the argument is not valid.
No.
He stated at the beginning that it was valid, though.
Yes, and by the way, he's talking about hidden preassumption, and this is how paradoxes are created, because paradox seems to be a valid syllogism, but it has hidden preassumptions or preassumption. But this hidden preassumption is not part of syllogism. And now he's saying that it is. It is not. And when Baby was making his presentation on Blue Marble Science, he said explicitly that the argument has only two premises and conclusion, three statements, no more, no less, as he said. And now he's saying that it may have more. No, it cannot. Two premises and conclusion. Why only two premises and conclusion? Why only three sentences? Because you have premise one being conditional statement and then middle term and conclusion. So we have three. Premise, middle term, which is second premise, but it is middle term we are searching for in argument, and conclusion. So only three, no more, no less. And now he's saying that he has something else. This is sophistry, I would say.
Yeah, I say proposition 28 is true, right? You don't need to worry about that. That's within Euclid. You cannot falsify a Euclidean proposition. That's ridiculous to claim. But hey, so he says, I said, proposition 28 is true. I'm not sure what you're saying. You're not trying to falsify proposition 28. So what's the purpose of your argument? Is it to confuse people like Charles? He says, I said, and I repeat, there is a hidden premise. You notice he's not saying anything about why he has a purpose of this argument, what the purpose of him doing it was. It's perpendicular logic. Like we agreed at the beginning, Chaiki, it works for a diameter and the tangents. And they are perpendicular, but you seem to be questioning every other use of everything that is perpendicular within the perpendicular argument. I'm asking Beddy why he's brought it. What's he doing? Because I don't have a problem with it. I can understand and see it for what it is. It's an argument about perpendicularity and the conclusions that you can draw mathematically upon knowing about the perpendiculars. I know how logic works as well, but I would never be so bold
You
as
have
to
no
deny
clue,
the
Bev.
consequent
You have no clue how
and
logic
affirm
works.
the antecedent. It's ridiculous.
You
Because
have no clue how logic works.
It leaves you in a middle ground, Chaiki, where you're having to falsify the middle term. That they're
Bev,
both meant to be fucking linked to.
You have not the first clue about logic. None.
It's crazy.
Zero.
You are not referring to what Bev said about he's going through these comments, and your statement is completely off topic.
No, it isn't.
Can you address this issue about first premise being false and second being true? And
No, I don't like to talk about what we talk about that we will talk about. Talk about we need to talk about. And when you talk logic, talk the logic. Don't talk about the logic.
Yes, we are talking about logic. About his
Again,
logic.
I don't want to talk about the logic. I want to talk.
Well, that's what we are doing tonight. Chaiki. We're talking
The
about
logic,
what
not
happens
about
is
the logic.
this is Betty's logic.
Well, you're not educated enough to talk about it.
Well, no, we are
Neither
just
am
going
I. I
over the
don't want to talk
comments,
about
and
it.
Chaiki, the problem is that
And you don't
there
understand the
is
comment, but you
there
have no
is
idea about the
cogdis,
logic.
Chaiki. You're gonna have to go back to your own Discord server because we're trying to go over this, and you are showing how triggered you get because Betty's
I'm not
brought
triggered
this
at all.
logic. This is what
I'm not
Betty's
triggered at
logic's
all.
going to
You're
do.
going into
Don't worry about it, Chaiki. It's going to be plenty more people
Betty is
just like
educated. He
you
learned
that
logic.
have this
He
problem.
learned logic. You don't understand what Betty says because you didn't learn logic, and
It's
you
dead easy
dismiss
to go
everything he
over
says.
this. This is
It's not
perpendicular
true.
logic, Chaiki. You couldn't make it any simpler, really. I mean,
He's
the
talking
proof
about-
of this is the straight line, but I mean, like, this is the proof of the straight line at the same time.
Yeah.
Yeah.
Okay, so Chaiki, if you are, if you think that we have no clue about logic, then can you tell us what he's talking about when he's talking about missing premise?
I have no clue because I don't have a Betty's education about logic. That's why I'm not talking about it.
But he's saying that the missing
Want
premise
to
is
clarify?
obvious.
You want to clarify with Betty? You take it with Betty, not with me.
Yeah,
He's
Betty,
saying that-
we're going over the comments, and Betty obviously is
all,
like you.
That's how you learn things.
ECV, this is what
Why
we
you
call
need the
Chaiki.
university? You can go through comments.
Right, if everybody's listening, not many people I know, what we call this is ECV. An inability to address the issue right in front of you. And you'll have noticed it in chats and all of that for quite a long time.
Right when I
They
point
have
to Beth
different
that
tactics.
he is not have the education to talk with Betty about logic, his scope
Betty
is
can't
kicked
talk
in,
about logic.
and he brings up ECV.
No, Betty can't talk about logic. If he were a classically trained logician,
Oh, sure he
he'd
can.
be able to talk about it. But he can't.
Well, he is able to talk
He's
about
not.
it.
He's in
words that I
aporia.
don't
and
understand.
He's placed you guys in a state of aporia. By giving this argument. This is Betty's perpendicular argument. But he's unaware of how troublesome it is. It's what we're going over tonight, Chaiki. He's turned a modus ponens into an aporema, but it's model-induced aporema. And I know you don't know what that is, because probably nobody else will. Look it up, it's a moth. But there are traces of it. It's been scrubbed from history. Because it's troublesome to people like you. But Betty's brought it to you. He's literally brought it in and dropped it on your laps. He did it first with t-shirt logic. Nobody really wants to address that. We ended up calling that Betty's cross. But that did a number on poor Bob. Now Betty's brought this one. Now you've got Flat Earth Charles that's trying to help Betty to falsify Euclidean geometry. How'd you do that, Chaiki? Have you got any idea?
Oh, he left, I think.
Oh, is he gone? Oh, well, that's
He's on a
all right.
call with Rumpus. He'll be back.
He's getting in his instructions. Well,
Yeah,
I mean,
yeah.
it goes to show you, right? No one is going to talk about this ever. This is too hard for anybody to deal with, and it's I'd say, a discovery of tactics and all sorts within this. But a troublesome mind, right? Like, really troublesome. And I'd say, well done, Betty. This is brilliant. Anybody get onto this argument? This is a real argument. Like a real argument. And for discussion about perpendiculars. Are they perpendicular is the question. Because there is a necessary consequent of perpendicularity, and that leads to parallelism. People have been running from it and hiding from it. They've even imagined that they've done some wondrous things to what they call the triangle axiom. But basically everything we've been doing for years has come down to this. And yeah, there's no escaping this for them now. So let's see if we can see. I'll give a short recap. Beddie's made a perpendicular argument. It's been pointed out to him that some people want to both affirm the antecedent and deny the consequent. Well, if you deny the consequent, like a modus tollens, you say not Q, therefore not P. So you deny the antecedent. Or you affirm the antecedent to affirm the consequent.
Yeah, you cannot have this combination like affirming antecedent in order to deny consequent. This is impossible.
Yeah, it leaves you in a state of aporia. But what Beddie's solution to that has been to say that the Euclidean principle of proposition 28, the middle term, is the one that must be false. Well, that's a brave move for anyone to make, literally.
It's ridiculous.
It shows madness. I think they had this, they called it the disease of the learned.
That's a good saying. Yeah. I like that. Yep, that's the one.
I think it was in Kant's time or when they were all going mad. All of these philosophers, because these are the sort of things that you have to put your mind to in order to take on that dogmatic model. Because that's all it is that's keeping hold of this. Right, so we've got to this point now, right? Now, Beddie, being a logician or a claimed logician, realizes now that Charles has, I think what Beddie wanted to do was to say that they're not perpendicular, right? Which is what I would have done, because I still say, well, it says it in a bit, but they're angles. They're not really lines, so it's a bit difficult. It's just at a point. I don't have it as lines, but I mean, again, the geometric takes you into all sorts of problems. But he's found that Charles, because of Beddie's side rule, is now in play, that he can't go against Charles, flat Earth Charles. So he's had to try to find a hidden premise is in now. He's occulted a premise somewhere that isn't in the original argument that I'll go back to show you at the beginning. Here he says, the argument is valid, QED. Right, so he said it is valid, but now he's saying, I said, and I repeat, there is a hidden premise. It was valid at the beginning, and now there's a hidden premise appeared. This is sophistry, like Paper said, obvious sophistry. But be aware, you've met people like this. It's called shifting the goalposts, this sort of.
Yep.
And I say it's a dishonest argument then. State your argument in full and don't leave anything in your imagination. And now he says, Beddie, clearly the argument is invalid. The missing premise is obvious, and surely with your extensive knowledge of logic, you can spot it. Over to you, or perhaps your friends Saragaki or Mike or Paper will help.
Okay, so he said that this is valid, assuming that the premises are true or whatever he said at the beginning, and now he's talking about the same argument that it is invalid. He is not very well, I would say.
Contradictory, right? He's contradicted himself with his own thread and his own argument. And people like Chaiki and Charles can't see any of this. They're oblivious to it because Beddie's side rule's in play. If anybody's not aware of Betty's side rule. It states that you should always support your team and always boo, never cheer on the opposite team. And that's what's happening here. I don't know why, because it's better not to be on any team, and then you don't ever have to have Betty's side rule apply. Just be on your own side and make your own decisions. Don't ever be led by anybody. He's put, it's quite clear what the missing premise is. It's model dependent. The state of aporia is only reached by the person holding the belief they can falsify Euclidean geometry to hold a contradiction given to them from a dogmatic belief system. Thanks for bringing it up. I'm sure the conversations will flow from this, because it is. This is groundbreaking. Within the mental state of anybody that holds this model, they will have to be forced to look at their own understanding of knowledge and whether they can break a reasoning process, how easily they can do it. Most people get triggered, I think, that I've talked to anyway. He says, no, that is not the missing premise. Try again. Ask Mike or Paper or Saragaki. Now, this is another tactic that people do. He hasn't got a clue. He doesn't know how to solve this. So what he does is just turns it round on other people and asks you to try and solve it for him.
Absolutely. Reversal of burden of proof. So this is not missing premise because it is not missing premise. There are no missing premises here. It is only pre-assumption. As you said, model dependence on model is pre-assumption. It is not part of syllogism. We have two premises and conclusion in his original statement, and it is perfectly valid. There is no hidden premises here, only hidden pre-assumption about model. And that would be that. No missing premise.
I put and then I put there's a timestamp there if you want to go and listen to it. It says, you said last night that you thought your argument was valid. Perhaps the missing premise is your contradictory state, or maybe diletheism. And then Betty says, the argument is not valid without the missing premise.
Yes, but there is no missing premise.
But it was valid. It was valid without the missing premise, and now it's not valid without the missing premise. I mean, this is obvious
sophistry.
Obvious sophistry. And surely people have seen this sort of stuff. You know, you should be used to this. Go to any chat room. This is the regular sort of thing you'll have to deal with when you're talking to somebody. They just contradict themselves. In fact, they don't even know what a contradiction is. That's how bad this understanding of logic is. Here comes Charles, Flat Earth Charles. He says, I'm biting my tongue not giving away the missing premise. As if he knows, right? It's like he wants a part of the Team Shadow Giants. Betty and Charles. Flat Earth Math and the the proofless dogmatician.
They are trying to set up some narration about missing premise, which is not non-existent in that argument.
Yeah. Yeah, I mean, like I hope at some point in time somebody might look back on this and go, this is the Plato sort of thing of the time.
Yeah, they are creating a thing that does not exist.
This is the modern sophist. But they're not even
Yeah,
here.
what
They're not
missing-
even trying to gorgy ass this shit. They're just
Yeah,
doing
what
it in
missing
text.
premise is there?
No, there is no, and
He wants
that's
you
why.
to think of it, right? The
But there isn't
moment
any.
you think of
Yeah.
something, then you are making that missing premise for him. This
Ain't
is the
gonna
magic
happen.
trick. Yeah.
Yeah.
Yes, this is a perfect example as described in Sophist, Plato's Sophist.
Yeah.
They are creating a new entity which does not exist, and they are trying to make you to think that this, which is not existent, is missing.
Yeah, they're trying to make
Well, it
you
doesn't pass go here.
trying
so
to make you make a not that into a that by thinking about it.
Yeah.
just like Monopoly, you can't pass go, you can't collect 200, something like that. No.
No, there's a nothing there, right? Not
Yeah,
that.
that's my whole point.
But the moment you think of it, you are making it into a that, right? Then you can talk about what you think the missing premise is, and they'll enjoy that conversation.
Yeah, but I did not, and we
Yeah.
did not do that.
No, I
Yeah,
know.
because-
We're getting wise to it, but this is what we've been learning.
If they are saying about missing premise, you automatically think that there is some premise
Yeah.
which is missing.
Yeah,
But
they
there is
want to
not.
get you to think about the not that.
Yeah, if
Yeah,
we
yeah,
weren't doing
exactly.
logic, right, they'd get away with this. Right? Because who else understands it? What are they talking about? What's a missing premise? It means nothing to anybody else. But to us, because we've been looking at it, it's the whole basis of understanding through logic. This is how you know things. This is where your knowledge comes from. And these guys are just messing about with it. They're playing. And it's not good for people. In fact, it's really bad for people because this is what happens. Betty is leading them like the Pied Piper to Aporia. And he's forcing them to do it. It's not us. Betty's put this perpendicular argument down. And I can guarantee you, no one can deal with it. They can't put their minds to it because it's unanswerable. Places everybody in a state of aporia. And he's trying to get you to go there. And then I think they go to the team, Stefan Mudd. Still no reply from Bev regarding the missing premise. I wonder why.
Developing narration.
Yeah, because I've seen the fucking game. I know the game. And there is no missing premise. It's missing because it's not there. It's a not that. And then Betty says, well, perhaps he couldn't spot it. I suggested he contact Paper, Saragaki or Mike Jones, but no reply so far. Saragaki claims some expertise in predicate calculus. And we're going for the occulted premise that Betty's hidden somewhere.
So they are
The
trying
ghost
to...
premise, like the ghost particle. We have the ghost premise. I like it.
So Charles has already told us your diletheist axiom you've occulted. And Betty again. So what is the missing premise then? Perhaps Saragaki could help. I have to point out, there's still no answer from Betty as to why he decided to bring this particular argument in. I still don't know what he's doing. Why he's done it. I like it. I like the idea that people are doing logic. But we've always said there's a certain group of people that don't seem to be able to do logic because they've extracted self-evident truths from their logical system and ended up with there are no proofs. And it's called modern science. It's got nothing to do with old science and old school ways of learning things. This is modern science. There's no proof in anything, and you can't even use Euclidean proofs in reality anymore, which is why they have a problem. Yet Beddy, the genius that he is, has brought a perpendicular argument and landed it on their laps. And this is where it starts getting more interesting now, because obviously the initial argument has flown a bit, and they've got into the idea that there's a hidden premise that can falsify premise 2. I mean, this is big news now. The team's on it. You'll see more and more people. Maybe Rumpus, get Chaiki.
They are trying to convince some people that there is something into it, but there is nothing, in fact. So they are trying to produce something from thin air.
I said, the occulted premise you didn't place in your perpendicular argument that you said was valid, but invalid without the occulted premise. And Beddy says, that's the one. What is the hidden premise? As asking me. Charles has guessed. Charles just guessed it. I mean, if a complete random dude who knows nothing about logic can guess what it is, who knows? 'Tis globe. Obviously. I mean, right? He says, Charles, have you asked Saragaki? He will know. Also, Paper or Mike, especially Paper with his extensive knowledge of Euclid.
I have no extensive knowledge of Euclid.
He's like, what he's doing is he's buttering up his sword, right? Because he's going to slay a few giants as he makes his way to be a shadow giant.
For me, this is just a mockery.
Yeah.
He's mocking us.
No, he's mocking them, I think. I think it's
maybe them also.
It's good for us because it gives us a chance to have a new rhetoric for an argument, right? I do really think this is a good argument, perpendicular. I mean, how simple can you make an argument and then place these, 5 different terms for perpendiculars? I think people would agree that they're perpendicular. I'm pretty sure most people wouldn't have a clue what latitude and longitude are, other than within this arena. But everyone else would know all of the other ones, right? For perpendicular, vertical, horizontal. You could even teach, show people what perpendicular is and how all right angles are equal. There's geometry lessons, mathematical lessons within this. So I like it. I thank them, Beddy, for bringing this argument. Johnny Ragadoo, I think he was Flat Earth Charles's friend. It says, interesting. In spherical geometry, straight lines are great circles. Any 2 circles intersect. So there are no parallel lines in spherical geometry. What parallel lines are you basing your perpendicular argument on? He's asking me. I say, it's Beddy's perpendicular argument. We're talking about his argument here. And then he says, so why all the fuss? Lines of latitude intersect all lines of longitude at 90 degrees. Lines of longitude are not parallel. Affirming the antecedent, denying the consequent. Lines of latitude, although called parallels, are not parallel either.
So if they are called parallels, but they are in fact not parallel, it means that they have no 90 degrees between them.
Fantastic, isn't it? Like, contradict yourself within a statement and not see it. He says this is because the surface of latitude and longitude are drawn on is not flat. Even if it makes perfect sense to consider the surface of a sphere two-dimensional, even if it makes perfect sense to consider the surface of a sphere two-dimensional.
It doesn't.
It doesn't make perfect sense. In fact, it's crazy. Sphere's non-developable. You can't express it on a plane. So crazy. But I mean, these are the guys. He says, I don't see any contradiction.
Maybe because he's blind. Okay.
Well, if he doesn't see a contradiction,
like you.
he hasn't got a clue about logic.
You don't see a contradiction. I can see contradiction.
There was no contradiction here.
There's no contradiction in that.
Contradiction is that they are
lines of longitude are not parallel. Lines of latitude, although called parallels, are not parallel.
No, they're an Euclidean straight line.
Does that not sound like a contradiction that you call something parallel, but they're not parallel?
No, you cannot have these big, great circles cannot be parallel. So even in spherical geometry, there are no parallel lines. So you cannot.
What did you say? You said, did you say spherical geometry?
No, this is about...
It's spherical trigonometry, and if you count them as circles, then they can be perpendicular and parallel. The latitudes are circles.
I thought you don't believe in spherical geometry.
Parallel. They're called parallel, and if they're circles, then they are parallel. They're like slices.
Yes, you can have parallel planes.
Planes you can have.
Yeah.
Yes, if you draw a circle on a sphere and bigger circle on a sphere, you can have, from that, you can have parallel planes.
You're doing mistake left and right. Can you draw a circle on a sphere?
You can slice sphere into...
Can you do that, Bev?
What?
Did you approve you can draw a circle on a sphere?
You can
Let
draw...
me be paranoid a bit.
Let's say you can draw circumference on the sphere, and then you are creating circle. Not on the surface of the sphere, of course. And these circles you can have being parallel to each other. So you can slice through a sphere in a parallel, let's say, way, and you can have parallel slices through sphere. No problem.
Okay, so I mean, we're going with what Johnny's saying. He doesn't see a contradiction, though.
Yes, we can see. He cannot see. It means that he is blind. Okay.
Yeah. And then Betty says Johnny has spotted the hidden premise, the unseeable contradiction. Perhaps it's hidden in the unseeable contradiction. You have to specify the lines of longitude and latitude are on a plane surface. Given that proposition 128 is true. He's going with the wording, not the perpendicular parallel argument. Slight twist. Are you any wiser?
No, if he's talking, you cannot have, so he's admitting that you cannot have straight lines on the surface of the sphere. But this is not a hidden assumption.
I say to Johnny, you're contradicting proposition 28, book 1 of the elements, and obviously everything that leads to that. It's obvious you're a diletheist. You just probably don't know what that is. You should drop the model, try thinking without it dictating any dogma to you. And I also say to Betty, you already stated that you use proposition 28, and the fact that you used the word perpendicular showed that you were using Euclidean geometry. You can't occult to not that within your argument. Nice joke you played on Fem and these guys. Because it's a joke. And if anybody's fell for it, well, it's because you don't know about the characters within this arena. Johnny Ragadoo says to me, or could it be that you are trying to apply principles of plane geometry out of context?
Out of context?
Perpendicularity
and parallelism is planar geometry, yes, within planar geometry. So
yeah, he used it within the premises of his argument, right? You can't say he wasn't using it. The hidden premise was that he wasn't using Euclidean geometry, which was the foundations of his argument.
Yeah, but he was. In fact, he was.
Now you tell him what he was using and what not, huh?
Right.
Cook this.
Do you think that Betty says to me and to you, everyone, we did go over this. Do you think that latitude and longitude are not perpendicular? He always likes to do a not that. What about you, Shaiki? Do you think that latitude and longitude are not perpendicular? Takes a bit of extra time because he put that not in there, didn't he? It confuses people. Don't worry about it. A lot of people would have to do that. You have to think twice, maybe even 3 or 4 times about it, because he's put that not there.
The funny part of that is that people, let's say on globe side, or like Chaiki, think that Baby is playing with us.
Yeah.
And he's making that impression for you, Chaiki, that he's playing with us. But in fact, he's playing with you.
No, he plays with you. I caught what he said right at the beginning. I told you, you make a mistake. You assume straight lines, straight Euclidean lines. I caught it from the beginning. He played with you.
Betty's
you keep talking
rule.
about it. The case is closed.
Betty's side rule
the case is closed, and you
play.
still talk about it.
Right, Chaiki? You've heard of Betty's side rule, have you?
Is there sides here?
Or are we just discussing
what I said and when I said it?
Are we discussing an argument?
You have no argument. You don't know how to make an
Betty's
argument.
That's right. We're discussing Betty's.
No, Betty didn't make an argument.
Yeah, he did.
Betty made a lesson.
That's what we're here talking about. Well, it's a lesson. Well, that's what we're going through. Because I'm pretty sure everybody is still not understanding where we are within this lesson.
Speak for yourself. I do. Speak for yourself. I do.
No, you haven't even got a clue yet, Chaiki.
Cook this.
He says
I say I do. You say no, you don't.
Betty says to Johnny, he thinks that curved surfaces are planar. This is incorrect. I mean, where would that come from? Who thinks that curved surfaces are planar?
You?
I don't. In fact, I know that curved surfaces are not planar.
So why do you think that that east, west, south, and north are straight lines?
They're perpendicular. They're known as perpendicular.
Yes, on spherical geometry, yeah.
Okay.
Not on your Euclidean one. So
I said the poll said that 62% said yes, they are perpendicular. Latitude and longitude. So that's 62% of people think that latitude and longitude are perpendicular. I said I didn't vote as I know they are just angles.
Just angles.
Yeah, I say to Betty, I believe that latitude is an angle and longitude is based on time. My beliefs don't affect your textbook perpendicular argument, though. And as we know, perpendicular is an angle, and angles are plane rectilinear angles, which means you were making an argument within Euclidean geometry.
Again, can you repeat? Angles are?
Rectilinear.
All angles are rectilinear?
And angles are plane rectilinear angles.
All angles are plane rectilinear angles?
An angle, right? Let me tell you again, right, Chaiki? Listen. Are you listening? My beliefs don't affect your textbook perpendicular argument, though. And as we know, perpendicular is an angle. And angles are plane rectilinear angles, which means you were making an argument within Euclidean geometry.
Are all angles rectilinear angles?
Yes.
Let's see definition 6 and 7 in book 3 of Euclid Elements. Please, Bev.
No, we're talking about
definition we will not
9,
see it
Chaiki.
because we have non-rectilinear angles there, right? Cog this.
No, we have a straight line against straight line.
Can we
Two
have
straight lines?
Are those rectilinear angles?
Yes.
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 Really?
Yes.
A
Plane
straight line in a curve is a rectilinear angle.
Like a zenith angle.
Is it Pepper?
Like an azimuthal
is it
angle.
Pepper? Are those rectilinear angles, Pepper?
Which ones?
Those in definition 6, 7, book 3 of Euclid Elements.
He's talking about the book of circles.
Here? Who has cogged this?
It's got nothing to do with angles.
He's talking
All you have to do is bring the picture of those definitions, Bev. You refuse to do it. That's called cog this.
I've not got the definition of an angle out, Chaiki. I don't understand.
Just show me that it isn't.
We're going over the
All you have to do is show this picture of this page in the book.
There's no such thing as an angle that can be measured that is not a plane rectilinear angle. All angle measuring devices measure plane rectilinear angles.
You don't know the first law of measuring
Yes,
device.
and this is right, because geometry is about measurable quantities.
What?
And these quantities that you can measure. This is
Euclid doesn't measure anything.
Yes, but he is
talking. He doesn't measure anything.
Yes, I agree with you. He does not measure anything, but he is talking about that kind of quantities, like length, that can be measured. And angle to a curve,
of a segment, rectilinear.
Angle to a curved line cannot be measured. That's why Euclid is not dealing with that kind of.
Really?
Yes.
So how does he compare them? How does he compare them in proposition 16?
He is talking about that you cannot use that kind of angle to anything.
No, he doesn't say that you can't use it. No, he doesn't. No, he says clearly that they are not less than 90 degrees or more than zero.
He's trying,
or more than zero. That's quantifying.
He's trying to prove that there is
no,
only
Euclid
one point.
Try to prove. Euclid proves.
This is only corollary to his proof that you can have only one tangent point when
no,
the
it
tangent
only
line.
Proves
yes,
you
it
that
is.
The angle between the diameter and the circumference is 90 degrees on the inside and 0 degrees on the outside. That means a right angle. Yeah, he does.
Not he's saying that
we can go
on
over
one side
it, please. We can go over it with the proposition.
You can
walk through it. It's a difficult proposition. We can go through it.
It is not difficult. He is proving by
Very
reductio
difficult.
ad absurdum. This corollary is proved
Another
by.
word you made up.
You are
Not
interrupting.
reductor and not
Sorry.
absurdum. Everything
It
Euclid
is,
does
yes,
is
it
a
is.
proof.
He says that this is
QED.
impossible. You didn't read that carefully, that proposition.
I read it carefully on at least 2 different books.
Beddy put a QED at the beginning of his
But you
argument.
refuse
Remember
to
that,
go over
Jakey?
it now. You refuse to go. I said not all angles are rectilinear. You say they are. You
Yeah, yeah.
refuse to bring the
He
definition.
said that there are no measurable angles, which they are not.
Angles don't need to be measured.
Yes, they have to
The
be measured. Yes.
definition of the angles, and not all angles are rectilinear.
Yes, they
Simple fact of life defined by Euclid.
They have to be measurable because otherwise
No,
they
where
don't
does it
belong
say
to
that
geometry.
rectilinear is
Definitions.
measurable?
Is Shaky just going to definitions and claiming definitions?
Yeah, I love Euclid.
Is that,
I told you,
is
he's
that
my
what
hero.
you're going to use to falsify
I'm not
the
saying Euclid is
perpendicular
what you
or
say
the
now. I don't
parallel
like
of
it.
Beddy's argument, Shaky?
I don't dismiss Euclid just because he says something that doesn't.
Okay, so
fit
does
with
that
my
change
worldview.
what a perpendicular is within Beddy's perpendicular argument? We seem to be getting a little bit off track.
No.
But perpendicular is an angle, and it comes right after the plane rectilinear angle. In fact, it's the next definition within the axiomatic system
Euclid
of
framework,
Euclidean geometry, the foundations of mathematics.
I agreed from the beginning. In Euclid framework, it does.
Okay, right. So that's where we get the definitions from. So are you injecting something different into the definitions at that point, or are you going to wait till after that?
No, I didn't. Beddy did.
Okay, so you're going to
change.
Are you changing that definition, Chaiki? Are you saying that Beddy's changing that definition?
No, he didn't. He used another definition of another framework.
Okay, so he bypassed that definition, or did he use that definition? Because it's within the axiomatic system. If one piece falls of an axiomatic system, your logic gets exploded, Chaiki.
I need to know what an axiomatic system is.
Look up Euclidean geometry for the most
I don't want to look up. I want you to tell me what it is.
System that there is.
Another thing you can't define, huh?
Yeah.
You say axiomatic system, but you don't know what it is. You can't explain what it is.
Anything that's framed around axioms, self-evident truths.
What's an axiom? What's an axiom?
A self-evident truth.
A self-evident truth? That's an axiom? Can I get the definition?
Of an axiom?
Do
you want an axiom? A quick one. Two straight lines cannot enclose
No, I want the definition from Merriam-Webster.
Go on, I'll look it up.
Why me? Everyone needs to see. No. All your audience needs to see it.
No, we're going
on
over
your screen.
Chat, and
Go ahead.
Obviously, Chaiki. Remember, we're going over. Remember, we're going over the cog dis and how people react to this argument that Beddy's brought in. Chaiki. Remember, that's what we're going over. Beddy's perpendicular argument and the distress it causes certain members of the community. And we're trying to see how widespread this is, how far it goes, how deep it goes, how ingrained in society is this problem of people that hold contradictions that cause this, I don't know, would you call it distress? You seem to be getting a little bit annoyed. I mean, we're not causing blood pressure to rise or anything like that, are we? I hope not. There may be a time that you might need to step back.
No, don't worry. I don't have any problems
or something.
Any heart problems or anything.
Okay. Well, just let you know that this cognitive dissonance is a problem. And lots of people will react in all sorts of different ways. We never know how that occurs in any of us. So can we get back onto this? Betty says a line of latitude is a line, and in geometry, a line's straight. I.e., a set of points. A line of longitude is a line. Another set of points. A set of points is not. Do you want to Google line geometry? Have a look. Try it if you want. A set of points is not an angle. Did you think a set of points is an angle? Completely wrong. Also, as I said above, curved surfaces are not planar. That's like a non sequitur if you take everything that he said geometrically. But I mean, as we know now with Betty, he's a sophist, and there's a chance that while he's talking and using geometric terms, Euclidean geometric terms, he might not actually be thinking Euclidean geometric terms because he's a sophist. Likely to say or do anything, as explained here by the contradiction and talking about lines and then talking about curved surfaces. I say the shortest distance between any two of those points would be a straight line. Do you understand geometry? Latitude is just an angle to a light in the sky that doesn't move. Betty says, no. A line of latitude is a line. Look up at geometry. Line. Don't you understand geometry? A line is a set of points. Is it? Look it up. Google. Line. Geometry. I think Wolfram. I'll put it in the Discord, but although I haven't got the Discord on showing on the YouTube, so if you want to see what I'm putting in Discord, then come on into Discord. It's a Wolfram mathematics. Have a look at that if you want. It says a line is a straight one-dimensional figure having no thickness and extending indefinitely in both directions. A line is sometimes called a straight line, or more archaically, a right line, to emphasize that it has no wiggles anywhere along its length. While lines are intrinsically one-dimensional objects, they may be embedded in higher dimensional spaces, like 2D on a plane and 3D reality. And then it just goes on about, you know, line, but straight. So Betty's saying it's straight. I don't know why. I keep saying it's just an angle, but he's determined. I said, yeah, a line between 2 points is straight. Is a line between 2 points of latitude straight, or is it latitude just an angle, like I say? He says, no, wrong. A line of latitude is a set of points that all have the same angle of latitude. Again,
it doesn't make any sense.
I say it's just an angle, like I say, and he says, no, wrong. A line of latitude is a set of points that all have the same angle of latitude. So it's just an angle, but now he's making it into a line as well.
What the heck?
Line is not an angle.
Mm-hmm.
You need two lines intersecting to have an angle.
Yeah, latitude is just an angle. Like so many degrees of latitude, right? It's just an angle. It's a point at which an angle is measured. That's not a line.
Even if you are referring to the light in the sky, you have the straight line from your position, your line of sight. That would be one line, straight line, and the second would be horizontal.
Yeah, but it's just a line from, like Betty's saying, latitude is a line, right? Because he's seen circles on globes. Whereas I say, it's just an angle from that position that you are, right? It's a number that you write down at the position you are.
Yes, and this is vertical angle.
That's it. Yeah, it's just a vertical angle that you're measuring, but it's not a line. So you can't have angles being perpendicular to each other. That's the way I said. I didn't answer it. Like, this is Beddy's perpendicular logic. I'm not part of it, like, because he used latitude and longitude. Now, you want to use vertical, horizontal, north, south, east, west. I mean, perpendicularity works, but not when you've got angles, because that's not a line. You can't do that. So, I mean, this is why I find it interesting. Beddy's brought the latitude and longitude in and brought in with a perpendicular argument where, like I say, it doesn't really belong together, but it's caused people to think about perpendicularity. I say, if you measure an angle at one position and then move to another position and measure the same angle, the shortest distance between those two positions will be a straight line. He says a line of latitude is a set of points at the same elevation. Now, this is important. This is where he first introduces this hidden premise, the hidden premise. Right, this one was well occulted. This is where it comes in. A line of latitude is a set of points at the same elevation brackets and the same angle of latitude. Do you disagree? So he's added in elevation now as well, the angle. And a set of points. I say elevation now too? Question mark. I've heard mention of elevation regarding latitude. I thought it was just an angle. What elevation do you imagine latitude is? He says, like, after asking him, like, what elevation would you imagine at latitude is? Anyone?
It doesn't matter.
Yeah. I don't know why he's brought it in. It's just very strange. But I mean, hey, this is Beddy. He says latitude is given as an angle that ranges from -90 at the South Pole to 90 degrees at the North Pole, with 0 at the equator. Lines of constant latitude. So notice there were 3 angles he showed, one of them being 0 degrees. Lines of constant latitude or parallels run east-west as circles parallel to the equator. Parallel. So he's using these geometric terms again. He said they're angles by definition. Oh, that's me. No, a line of constant latitude is a line, not an angle. You even wrote lines of constant latitude. This was the definition of latitude. Lines of constant latitude are parallels run east-west as circles parallel to the equator. That's the definition. I say they're angles by definition. Angles. He said no, a line of constant latitude is a line, not an angle. You even wrote lines of constant latitude or parallels run east-west as circles parallel to the equator. That was the definition of latitude. Note the bit that says as circles. Are you saying that a circle is an angle? I say your perpendicular argument is working brilliantly. Thanks for sharing it. Could we get the textbook you got it from so that we can learn some more practical arguments to use, please? If you're out there, Beddy, give us a heads up on that book. This looks like a good argument, the perpendicular argument. Beddy says, so we finally agree that a line of constant latitude is a line. It took a while. Can you see that? Your perpendicular argument is working brilliantly. Thanks for sharing it. Could we get the textbook you got it from so that we can learn some more practical arguments to use, please? His reply? So we finally agree that a line of constant latitude is a line. It took a while. Like, he's imagining shit now. There's nothing there.
So maybe he's discussing things with himself.
I think so.
I don't know.
So lines of constant latitude run east-west, as you rightly say. Lines of constant longitude run north-south. And north-south is perpendicular to east-west. Alles isco. I don't know what that means.
All is all right.
That's all good.
All good.
So north-south is perpendicular to east-west. So he's now brought in north-south and east and west. Well done, Betty. Another one. Perpendicular argument. He says it's all good. So it's all good now to use north, south, east and west within Betty's perpendicular argument, because longitude and latitude are north, south and east and west. There's no difference. They're perpendicular. I said, do you imagine much about agreement? Are you bringing in north, south and east, west into your perpendicular argument now? Too? Notice that I've not really got into this argument. Betty's made an argument and it's causing problems even for him. He can't even talk about it. He's running from his own argument. Can't talk about it. There's loads of other people that can't talk about it. In fact, probably nobody can ever talk about this.
If he's talking about perpendicularity, it means that they cannot be circles.
Bev, you're talking about it for 2 hours now. What do you say? Nobody can talk about it.
Yeah, I'm talking about it, yeah. Because I'm explaining to everyone exactly how this perpendicular argument that Betty's brought in, I'm doing it all for him. I'm explaining the whole thing. Letting everybody right into it. I mean, we haven't even got to the really good stuff yet. There's hidden depths. This is advanced
Sure, you
simplicity.
dodged everything I asked you. Everything I asked you, you dodged this cog.
You can, if you got put the axiom, the statement accepted as true by
I
the
did.
basis
Yeah,
of the argument.
which definition of axiom you use?
What do you mean definition? He said what axiom is self-evident truth.
I don't care what he said. I want to care that and care about the definition
You see the
everyone
one that
used.
says self-evident
Everyone
truth, Jackie?
used.
Yes, this is definition which everyone uses. And
No, I
everyone-
posted the one everyone uses. Pepper.
Where did you post that?
It's the beauty
Like
about
that.
Euclidean geometry. You can see the axioms laid out bare. They're right there in front of you. You can see what they are. You don't need to read
What
a
does it say?
definition.
What an
You
axiom
can
is? What an
actually
axiom is?
see the axioms. You can
According to
agree
Merriam
with them.
Webster.
You can go, oh yes, they are self-evident.
No one says self-evident. It says there.
I do. Did you not hear me then, Chikey? They are self-evident. I said, yes, self-evident truths.
No, I know you do, but nobody cares what you say. Everyone goes by Merriam-Webster.
Yes,
does it
it's
say
in the
there?
definition.
Yes,
I know
an
your eyes are bad,
established rule.
Chikey, but have a look. It says it, in the definition.
An established
No,
rule
the
or
first one
principle.
says accepted. The first one says accepted.
Hello,
is
Jackie.
true.
An established rule or principle or a self-evident truth. Why do you oppose? You brought that, and now you are denying that?
No,
Entry
that's the
two.
second one. That's the second one. The first
Yes.
one is
It is,
accepted.
yes, yes, second
So
one.
there are
yes.
different. There are different. So what does it tell us? What's this axiomatic system is? What
So you-
when you say axiomatic system? What
Okay,
kind of?
okay, so you say that the first entry is contradicting the second?
No, I haven't. It's different definition.
So okay.
However, what does it add when you say axiomatic system? What properties it brings? What kind of traits this word you introduced, axiomatic, add to the system?
Axioms theory is based on axioms, not axioms. Axioms are not based on theory.
No, so they are based on acceptance.
No, for example,
Yes,
axiom
acceptance.
is
Everyone agree. Everyone agree. That's an
yes,
axiom.
yes.
So
For
what?
example, that the
So
whole
what kind of system is it?
in
A
any
system that
in
everyone
any
agrees.
system, any system. For example, that the whole is greater than part. This is axiom. Can you show me the example of theory where this axiom is not working? Or another axiom that whole is not a part.
You think that's by definition?
No, this is I gave you just example of axiom.
Okay, so what? What it does it has is that you must understand this axiomatic system. It's just assumptions.
Yes, yeah, absolutely. Yes, axioms are assumptions. Yes, and they cannot be proved.
So what? So what does it add to the system?
That's why they are called self-evident. That's why they are called self-evident truth, because you cannot prove them.
You know, look can be deceiving. It looks like it's truth.
No. I am talking. How can you prove that the whole is greater than a part? How can you prove that?
No, you can't prove it. You define it
that's
like
why
this. You say a part is part of the whole.
Yes.
You define it like this.
So
it's not that this is a part of this. No.
Chaiki,
you say if it's less, then it's a part of it.
Chaiki, so it is self-evident truth or not? Axiom.
It can be. It may be not true.
I would say that
assumptions
it
can
always
be false.
is. It always is.
Assumptions can always be false. That's why they are assumptions.
Yes, but they are always true. That's why they are called axioms.
What did you say? I just said assumptions can be false. You said yes, and then they said, but they're always true.
Yes, but these ones are true.
How do we know? No,
you cannot
falsify.
You cannot falsify them.
You can fail about parallelism.
You cannot falsify axioms.
Yes, you can.
How? So you need to show
bring
me
your assumption and you show it wrong.
You need to show me black swan. You need to show me the thing which is a part that is greater than the whole. Can you
That's
do
by
that?
definition again.
It's not definition.
I can tell you this is greater than the whole.
Psyche.
And it depends on my definition of greater.
Psyche.
And your definition of whole.
You can prove an axiom, but you can't falsify an axiom.
No, you can only falsify it. You can't prove it.
Of course you can prove them.
No, it's assumption.
No.
Go prove me an assumption.
No, you can prove them.
How?
Self-evident axioms.
Can you say self-evident? It looks like it's straight. That's self-evident.
What, it looks like it's straight? That's not. That's
curved.
just a random statement.
The horizon looks
it means
flat.
nothing. It's not even a statement, actually.
The horizon looks flat, but it's not, right? We know it's not because there are waves there. It looks flat. It's accepted it's flat, but it's not flat. Falsified.
No.
Prove it that the horizon is flat. Go prove it that it's flat. You couldn't, right? You didn't measure the angles on your level.
Chaiki, horizon refers to your vision.
Whatever. Is it straight? Is it curved? What is it?
He's getting a bit off track again, Chikey. You're rambling. You are. We're talking about Betty's perpendicular argument. Why are you talking about the horizon?
He had no perpendicular argument. He had the argument you don't understand logic.
No, axioms cannot be proved in positive way. And what Beth was talking about is like trying to disprove axiom will lead you to absurdity.
No, it won't. It wouldn't. I just show you that the horizon looks flat. It looks straight. Bev claimed that plumb is perpendicular to the horizon. No, sorry, spot on. But it can't be because the horizon is not flat, and it can't have an angle to it.
Horizon is a line which you can see.
Is it a straight line?
Yes.
Yes, but there are waves in the ocean. How is it a straight line?
Because it is so
How do you
far.
construct a straight line?
I cannot see at the line of the horizon. I cannot see any waves.
Ah, the fact that you didn't bother to see doesn't make it straight.
It makes because
I take a telescope and I show you it's not.
I am not talking about telescope. I am not talking.
I don't care what you talk about. I just falsified what you said.
I'm talking about naked eye.
Did I falsify what you said?
Without magnification, you can see straight line.
Without magnification, people see better than me can.
People see without magnification.
Higher waves, yes, higher waves. 10 million different ways. You wrong, I'm right.
No.
Go on.
No, this is visual condition. Horizon is visual condition. It doesn't imply.
Show me how you make the perpendicular wave.
Horizon does not imply any magnification.
No, it doesn't imply.
Yes, it's a line.
I didn't say it imply. I say it's just not straight. And since it's not straight, you can't have anything perpendicular to it.
It is straight line. In your vision without magnification.
In your vision, which you don't see so good. But pilots can see the waves.
Yes.
Pilots can see the waves.
Horizon is
from 5 kilometers up. What are you talking about?
Horizon is limit of our vision. So
your limit, it's not limit.
It takes into consideration our limits of vision. Yes, that's right. It is limit of our vision. This is horizon.
Your vision, not mine.
Okay, so you can see indefinitely.
Wait, the wall in front of me is the limit of my vision?
Jackie, this is just stupid. Let's go on.
Can we carry on with this perpendicular?
I can see behind it.
You can't see through walls, can you not? Vision? Don't worry, Chikey. Keep thinking hard enough. You might be able to do it eventually. Seeing through walls. You can't see through walls.
Yeah, there are ways. There are ways you can see through them.
Okay, can I carry on now then? I say to Betty, north-south are perpendicular to east-west. Vertical is perpendicular to horizontal. Plumb is perpendicular to level. And the sides of a square that meet are perpendicular. I was giving you some examples of perpendiculars to see if they could work in your perpendicular argument. How many perpendiculars can you think of that will fit your argument other than your textbook lat long? He brought the argument. We're just thinking of other perpendiculars that will fit Betty's perpendicular argument. Betty says north-south are perpendicular to east-west. So we are indeed in agreement. Thanks. I said, yes, we agree that plumb and level are perpendicular. And Johnny comes in and says, and a parallel to a plumb constructed at some distance to a plumb is not plumb, but would still be perpendicular to the local horizontal at the first plumb, because horizontal is only level at the point of reference where the plumb intersects the surface. Got it? We're good.
Not, we are not good. No. He's implying something.
Yeah. And Flat Earth Charles says, absolutely. Level is perpendicular to plumb. Vertical always regards of distance or location on Earth. So level is perpendicular to plumb brackets vertical. So if he brings vertical in as well as plumb, you may as well bring horizontal in as well. So now we've got these, they're racking up. We've got level perpendicular to plumb, and vertical is perpendicular to horizontal. These are all of the perpendiculars for Bedy's perpendicular argument. And I said to Math, Charles, Flat Earth Charles, so do you also believe that these two perpendiculars violate Bedy's perpendicular argument as well? And this is where the shadow giants get in. He should have got in on this a bit earlier, Chaiki. You'd be pissed you're missing out on this. He says, do you also believe that these two perpendiculars violate Bedy's perpendicular argument? He says no, because level is curved surface, line, all along level. Perpendiculars are verticals are perpendicular to it, but the verticals aren't parallel because plumbs diverge with distance. So think about that, Chaiki. It doesn't violate Bedy's perpendicular logic, even though Bedy's perpendicular logic said about parallels being a necessity. He said, no, they are perpendicular and they're not parallel.
Yes, so he is denying conclusion. He is agreeing with premises, but he is denying conclusion. That's just nonsense.
Yeah, he's
agreeing with premises.
Yeah, for vertical and horizontal.
So flat earth math is defying logic explicitly because, as Beby said, and not only Beby, if premises are true, both, therefore conclusion has to be true. Flat earth math is agreeing with both premises, but he's denying conclusion. He's saying that it is false. It means that he is defying logic.
Yeah, it's a bold move, Chaiki. I'm no doubt he's doing this for the dogmatic globe, but he's literally trying to falsify Euclidean geometry through logic, right? He's just blatantly he's disregarding the logic, the Euclidean geometry, and going straight for the logic. He's denying the necessary consequent. It's a very bold move, but like I say, this is where the play's being made, right? Because everybody else was tap dancing and working around this particular argument, whereas Charles, he's just gone straight in there. He's the man. Now Charles is the man. He's the flat earther in charge. I said, is that not a violation of Bedy's perpendicular argument? I mean, it sounds like you're wanting to deny Bedy's conclusion, but affirm the first premise. I guess you've worked this out with Bedy. It's a contradiction, but only in the way that you want to deny the consequent, while having the lines being perpendicular. Hopefully Bedy will throw some more light on this. Because there's a problem. Everyone can see there's a problem there with what Charles is doing. Paper spotted it easily. But I don't know how much everybody else is really involved within this logic. But the rhetoric that we're learning at the minute is going to help us be able to show people this very simple perpendicular logic and how it has to be. Because Charles is showing you what has to be done for the dogmatic globe. There's no way around this. So this is why I was saying, I don't know what Bedy's done. I'd like to know why Bedy brought this particular argument in.
Do you have to be an expert in logic to catch such a simple thing? I mean,
well,
really?
We have been going over logic. Everybody else left it as soon as a black swan turned into a photo of some cranes. That's where everybody else left logic. Whereas we knew that that was a fallacy, right? That was a blatant denial of logic. So we've carried on, we've learned, and it is simple. But if your mind's clouded with these contradictions and you don't have a firm footing of understanding, then I don't know. Like, that's what we need to talk to people about. It's very simple. And it's an excellent way for you to be able to talk to people about basic perpendicularity. There's some great mathematics stuff in the simplicity of this. That's where we're going to be going. This is what they've been showing us, right? We've moved on. This flat earth stuff that Charles is bringing in, it's ridiculous. Time for it to just go. It's not needed anymore. So this is where a flat earth Charles really goes in for a kill now, right? He's one of the top guys. He's done the falsifying of Euclidean logic. I call it Euclidean logic. It's just normal logic, but obviously Euclid used logic in order to form geometry, foundations of mathematics, and number as well. There's lots of other things involved in Euclid's elements, not just lines and geometry. It's number as well. So it's all involved in that. So Flat Earth Charles says, first of all, as I've said before many times, Beddy's argument, the perpendicular argument, as you call it, was a challenge to you, to me, to find out what was wrong. And it was found in the second premise, which was false. He thinks he's falsified proposition 28 of Euclid. This makes the argument valid, but unsound. Secondly, your recent question was about level and vertical, and brackets, and the fact that level is perpendicular to vertical / plumb, which has nothing to do with Beddy's longitude latitude challenge. Like, I know there's getting things wrong, like, but I mean, he's fantasized quite a lot there, as flat earthers are prone to do. Can't help it. I noticed Beddy's side rules in play, right, Chikey? I bet you feel dirty about this, don't you?
Me, no, I don't feel dirty.
No, but you're gonna have to go along with it now. He's the big shadow giant. He's got math in his name. Flat Earth Charles. And he's talking about logic. He's talking about Beddy's perpendicular argument has turned to a challenge to me.
Wait a second. I think that flat earth mass is confusing something. In this argument, what was the second premise?
It was proposition 28.
Okay, but
it was the middle term, the one that linked the perpendiculars to being parallel.
Can you repeat the argument so we know what the second premise is?
His original argument maybe was referring to that, but I think it was about latitude and longitude lines, his argument. So I don't see any falsification, because if he is assuming that latitude and longitude are perpendicular, then of course longitude lines have to be parallel. And
yeah, that's what he says. He says any two lines of longitude are perpendicular to a line of latitude. Any two lines perpendicular to a third line are parallel to each other. So that's the Euclidean proposition 28.
So why flat Earth mass So why flat Earth math is saying that premise second is false?
Because he thinks he can falsify Euclidean principles. So he can deny the consequent. You can't have Euclidean proposition 28 linking being your middle term. He's trying to falsify that.
Why do you talk for flat Earth math? He can talk for himself.
That's what he's just said.
So he
didn't say. I didn't hear him say that he's trying to falsify Euclid.
First of all, as I said before many times, Betty's argument, as you call it, was a challenge to you to find what was wrong. And it was found in the second premise, which was false.
And I can read again the second premise. Any two lines perpendicular to a third line are parallel to each other. Chaiki, do you agree with the second premise, or you are rejecting?
Tell me the framework. Tell me the framework.
Premise one. This is
what framework I'm working with. Is it spherical geometry or Euclid?
Baby's argument.
No premise. What framework I'm working with? Am I talking Hebrew or English?
I'm saying again, premise one. Listen carefully. Any two lines of longitude are perpendicular to a line of latitude. This is first premise. Second premise. Any two lines perpendicular to a third line are parallel to each other. Conclusion. Any two lines of longitude are parallel to each other. This is original Baby's argument. And flat Earth math is denying second premise, which is, again, any two lines perpendicular to a third line are parallel to each other.
Because it's false.
So, you agree with flat Earth math? Or
they say that's false as well.
Both of them. I agree with both of them.
With both premises?
The premise is that the first premise is true. The second is false.
Betty's side rule.
Yeah.
So two lines that are perpendicular to a third line in spherical geometry are not parallel. What can you do?
He's not talking about
spherical geometry. You keep speaking English when they speak Hebrew.
Okay, but still, he's not talking about any spherical geometry here.
How do you know? Who said he's talking about longitude?
He's talking about perpendicular, Chaiki. Perpendicular.
Hello? No, he's talking about longitude and latitude.
He's talking about perpendicular
on a sphere.
And parallel.
And parallel. And in spherical geometry, you cannot have parallel lines.
Cog this.
No, it is your cog disk, because in spherical geometry, you cannot.
Spheres. He's talking about spheres. How can it be straight lines?
But he said perpendicular, Chaiki.
Because he said perpendicular. And
yeah, because his framework allow him to have curved lines perpendicular on a sphere.
Yeah, but this is impossibility.
Because why? Because paper organist said so.
No, because perpendicular lines create four equal angles. And with curved lines, or if one of them is curved, you cannot have four equal angles.
Huh? Who said four? Why four?
Four. If you intersect, you have two straight lines intersecting.
How many angles do you count on the corner of a cube of a square? I count one.
I'm talking about perpendicularity. You
perpendicular.
have two lines.
Are the two lines of the square perpendicular to each other? So the corner, how many angles do you count there? Why you bring numbers? Talk ideas.
Because you can prolong this sides.
Ah, you can. Of course
yes,
you can.
and
But
you
don't.
will have equal angles. Yes, 4 equal angles. Yes, first full circle, equal angles.
Same will do if you intersect two circles. You will have 4 angles that are right angles.
No, they cannot
no,
create equal. They
proved
are not equal.
in proposition 16, which you refuse to look at because you cog this.
And they are not equal. They are not equal.
Yes, they are equal.
No.
Yes, they are. If they are not less than a right angle, or they are not more than 0, they must be equal. Can you follow the logic?
Yes, and he's talking
Let's
about.
say I have an angle which is no less than 90 degrees. How many degrees in
Are you defending the flat Earth Charles's
I don't need to
denial of Beddy's perpendicular argument, or are you defending Beddy's original perpendicular argument?
No, you say he denied. He didn't deny it.
Who didn't deny it?
Flat Earth man.
Yeah, he did.
I don't know why he's not on mic and explaining himself.
Oh, you want him to come in? I said, like, I'm not too
sure. Well, he's typing in text. He hear you. Obviously, he can talk. I know he can talk.
He wants to.
So why isn't he?
Yeah, he should be coming in and explaining himself to you.
Why we need to hear your interpretation of what he said?
Well, there you go. That's all you need. Coming in here and explain yourself to Chaiki. You've confused the shit out of
me. To you.
You and Betty.
You're the one who said he says this, he says
no,
this.
I can see it. You haven't let me get to the best bit yet, Chaiki.
I didn't hear him say it.
It's the Aporema, the model-induced Aporema is coming. Trust me. It's going to be great.
The what? The what? That's something new.
The model-induced Aporema. I don't know how to say that.
Aporema. That's a new word.
That's a new word? Probably, yes.
Yeah, but for me, it's new. Totally new. For others, maybe 2 weeks.
Well, I don't know whether you can actually see it because it's one of those ECV things. It's been hidden for a reason.
By shadow giants?
Well, no, just because mainly by yourself, I think.
Well, hold to your pants. He's coming in.
Yeah. Okay, well, so we'll carry on for a bit because it takes him a bit to fire up his PC.
Oh, Jesus.
I say, so Beddy's perpendicular argument was an argument about perpendicular. The second premise is called the middle term, and it is that which links the antecedent to the conclusion. If you wish to think the Euclidean proposition false, you find yourself trapped within a fallacy of contradiction, but not a fallacy within the validity of the argument, but a fallacy of your own making. You should really talk with Beddy. I fear that you are exposing what I call a model-induced aporema. This aporema is a contradiction within the premises of an argument, but Beddy's perpendicular argument is valid in form. He's already stated this. The aporema is all yours. Your model affliction has shown you can take a perfectly valid argument into a contradictory statement. Clearly, you've unveiled a difficult topic for discussion, but these are the topics I'm personally interested in, and the combination of the proofless dogmatician and flat earth math has helped me find a way to explain something so complicated to the mind as a model-induced aporema. You should really come in and discuss this tonight. Now, that was me to Charles. Look, here he is. What an introduction.
Hello.
Hello, everybody. Thanks for the invite. I do appreciate it.
Yeah, welcome. You know, I don't like to speak for other people. Guess what they said or they didn't say. And certainly not here. Bev says they say something I didn't see they said.
Yeah, and there's a tendency of misquoting people or even just misunderstanding. You know, if you misunderstand somebody and you're like, well, Johnny said this, and Johnny really didn't say that. You just, you know,
We've
somebody
gone
just
over
might have
everything.
misunderstood.
I've said every comment that you ever said.
Yeah, but the problem, and I still don't think you get it, is that the use of the word line is you know, you're kind of crossing. Well, when I say you, Betty's challenge to you crossed the word line in different contexts, and it was kind of a challenge for you to figure out what was wrong with, you know, with that argument, because you know, both, like I said, both Betty and I know. And I think everybody agrees that latitude and longitude.
Sorry, can I just make sure you're talking about a straight line?
Okay, no.
Oh, I had this. Fight the Flat Earth did this ages ago.
Euclid,
he said that straight lines curve. Are you saying the same thing?
Okay. So Euclid's proposition 28 dealt with straight lines, actually specifically coplanar straight lines. Okay, and there's nothing wrong with Euclid's 28. I really, really would appreciate you not saying that I'm trying to disprove Euclid, because you've said that dozens and dozens of times.
You said it was false.
I never said Euclid 28 was false.
You said his second premise was false.
You see, Bev. You see, Bev. You say something.
Not,
he says he didn't.
It was not the second premise of Euclid. It was the second premise of Betty's challenge to you.
Betty's second premise was Euclid proposition 28. No. Yes.
Absolutely not.
Guessing, Bev.
Absolutely not. Okay, because you're crossing context.
No, maybe Betty is crossing.
If premise 1 is very specifically talking about lines of latitude and longitude, that is non-Euclidean geometry. Okay? So if premise 2 uses the word line, where premise 1 said lines of latitude and lines of longitude, premise 2, when it says line, it is not talking about a Euclidean straight line. We are no longer talking about straight lines in a plane. That was the challenge, and you never figured it out. Johnny Ragadoo had to kind of, you know, supply the cheat code.
Yeah, did someone say cog this? Bev, huh? Wow. Who said cog this from the beginning of the show?
Yes, cog this, yes.
Cog this,
yes.
Yeah. Longitude and latitude are on spheres, not on plane surface.
So Bev, this gets back to one of my points that I've made over and over and over again, and that is, you know, especially when people want to fight dictionary wars, is that words have multiple meanings.
That was Chaiki that was doing the dictionary stuff.
No, you guys were doing this long before Chaiki.
One axiom.
No, this is not Chaiki, because he has not been on the scene for like the last, you know, month, and you guys have been playing dictionary wars for a month.
Dictionary wars? What do you
mean? Meaning when somebody uses a word and then someone says, well, if you look up at the dictionary, you know, definition number 1 says this, you know, clearly the guy who said the word didn't mean definition 1, he meant definition 2. And so, you know, it's kind of like people talking past each other.
It's an axiomatic system, Charles. If you take in definition 2, you've already taken in definition 1. Axiomatic. Each step follows the other.
Webster is not an axiomatic system.
No.
Okay.
Pardon.
Okay, but you guys like to consult Webster.
Can you see that? I've put it in the chat there. Can you see that, Betty?
Okay, I'm sorry. I've been scrolling through.
Live chat.
Are we screen sharing YouTube
I'm screen
Studio?
Sharing the comments.
Yeah. It's YouTube Studio. Yes.
So I've also put it in the Discord live chat, so you can see it.
Okay, so which comment are we talking about?
The one where Betty puts proposition 28 right after premise 2. He puts it in brackets. That
you are showing me
proposition 28 is premise 2 of Betty's argument.
No, it isn't.
Yes, it is.
He says that.
No, it isn't, because it's longitude and latitude, which are not on planar.
Look, either on the screen or in Discord.
The words are the same. they are different. We're talking about
Can you
different things.
please, Beth, read that loudly again, please?
It
Our
says,
comment.
this is Beddy's comment talking to me. He says, I don't know what Charles is attempting, but it seems you agree with my logic. If the argument is valid and the conclusion false, one of the premise is false. Therefore, if premise 1 is true, premise 2, brackets, proposition 28, is false. I am glad we agree. So, Charles, are you aware that premise 2 in Beddy's perpendicular argument is Euclid, book 1, proposition 28?
Yes, but if you read the next sentence, what he's doing is there is the hidden
You
premise
said it was
in
false
that.
too.
It doesn't matter.
Okay,
You said it was false too.
He's not saying that proposition 28 is false.
He does.
Okay?
He says if
He's saying
premise 1 is true, premise 2 is false. Which is
Okay.
exactly what
Yes,
you said.
right.
You said premise
Okay.
2 is false.
Yes. As
But
premise
that's
2 is
Euclidean
false.
proposition,
Proposition
28.
Proposition 28 is true. Premise 2 is false in that series of steps.
No, proposition
Because-
28 is premise 2.
Let me explain it to you in simple words, Beth. To say proposition 2, to say premise 2 is proposition 28 is false. It is not proposition 28.
What's not proposition 28?
The second premise is not proposition 28.
Yeah, it is.
No, it isn't. It's the same words. It's not the same proposition because we talk on a sphere here, not on planes.
Any two lines perpendicular to a third line are parallel to each other. Proposition 28.
I said same words, different framework. This not the proposition 28.
But he's referring to proposition 28
No,
in Euclid's
he's not.
elements. No, he's not referring to any
No,
spherical
it says
geometry.
proposition 28 is false. It's not proposition 28.
It is.
No, it isn't.
Okay.
You insist it is because you cocked it and we explained it to you. We're talking about a sphere and we're talking not about planes. It's not proposition 28 the second.
Teamwork's amazing.
Proposition 28 is talking
Sophistry,
inside planar geometry.
It's the same word.
So my comment back to him was, proposition 28 is true. I'm not sure what you're saying. You're not trying to falsify proposition 28. So what's the purpose of your argument? Is it to confuse people like Charles? Because if you can't falsify proposition 28, that means, Charles, that you either deny the consequent or affirm the antecedent. You can't do both. This is logic.
The key is context. And the
No,
key
the
is
how
words.
far
the
you've
key is
took your
context.
mind to be able to falsify logic, which is what
I'm
you're
not trying to
doing now,
falsify
Charles.
logic, and I'm not trying to falsify Euclid. So, you know that I know you hear me saying the words, and I'm saying them over and over and over again, but you are insisting that you are mischaracterizing what I'm saying as trying to disprove Euclid or trying to disprove logic.
Mm-hmm.
So if what I'm saying doesn't make sense to you, what I would like you to do is say, hey, what you just said, Charles, doesn't make sense. Could you clarify that? Instead, what you keep saying is you're trying to disprove logic. You're trying to disprove Euclid. And I'm not doing either.
Charles,
so if you think I'm doing
here's what
either,
I'm actually
you're
saying,
misunderstanding.
Charles, I don't know whether you're hearing it wrong. What you're doing, you're stuck in a minute. You're stuck in an Aporema, but it's model induced. The actual logic is valid. If you have these perpendiculars, then the necessary consequent is the parallels. You can't break that necessary consequent because it's already in Euclidean geometry. So you either have to not have, if you don't have parallels, you don't have perpendiculars. That's the way logic goes. But something's telling you
only coplanar.
that you want
you're
both.
Forgetting the assumptions.
But you're,
yeah,
no,
that you're,
here's the thing though.
Straight line.
Here's the thing, right? You're not showing the necessary link between the antecedent and the conclusion, the consequent. You have no link. It's vaporized. We call that a state of aporia that you're in.
No.
Yes, you can't explain how you get your consequent from your antecedent.
By the way, sorry.
I haven't formally, I'm sorry, I haven't formally studied logic. All right. So I'm not really, like that's not my strong suit at dealing with that vocabulary. But what I am saying is that what Betty wrote to you was a challenge. And what he specifically did, and it was you can call it a trick, but he used the word line in two different contexts. Premise 1 used lines in terms of spherical geometry. Premise 2 was quoting the language from Euclid dealing with straight lines that are all coplanar.
Okay.
Which
Show
means
us
that
the definition in spherical
2,
geometry that mentions perpendiculars, please. Let's see that definition.
I don't have that off the top of my head, and I don't think I don't. Well, obviously, since Euclid,
well, you've claimed that Betty used it within his argument. So please, let's see that definition.
Well, the thing is, you don't understand the.
You wouldn't just be claiming definitions without actually having the definition after just moaning about people asking for definitions, would you?
No, I was not moaning about people asking for definitions. What I was talking about was people misusing definitions,
like
especially
people just making definitions up that aren't there and claiming.
No.
Well, let's see it then.
No.
Where's the definition
No,
in your spherical geometry that states perpendicular? What number is it?
Like I said, I don't have that. But the study of calculus.
Okay. Sorry, Charles. I have one clarification to the question. Do you agree that premise 2 is in context of proposition 28? Because you said that we don't understand. Because you said that we don't understand context. So can we clarify that Betty's second premise is in context of proposition 28?
No. He's just quoting the language.
No,
he's just copying the words.
So
but because the context is wrong, that makes the second premise wrong in Betty's challenge.
Okay, so next question is maybe, as you know, that you have to use in first premise and second premise the same words, because we are talking about subjects and predications. And if you are using the same subject, like line in first premise, so in second premise, if you are using the same word line, it has to mean the same as in first premise, because otherwise you cannot produce argument. Do you know that?
Yes. So
you say yes now, but you said differently, because you said that in first premise he is using a different, let's say, definition than in the second. So it would invalidate his argument. I'm sorry.
No, the argument is valid. It is unsound. So if you handed his argument to somebody who didn't know what any of the words meant, right? Like a syllogism where you say, all creatures that swim in the sea are fish, dolphins swim in the sea, therefore dolphins are fish. Well, that's an unsound argument, but it's a valid argument.
No,
okay?
It is not valid
because it contains something that makes it unsound.
Please don't deceive our audience. because you gave invalid example.
I gave
This
an
is
unsound. I gave a valid
about
example
this
that was
the
unsound.
dolphins. Yes, yes. This you are creating illicit minor and you are making fallacy. Sorry, don't give that as a good example of logic. Sorry.
But I hope you get my point, Paper. Is that you know, I use the structure of a syllogism. You know, everything swims in the sea is a fish. Dolphins swim in the sea, therefore dolphins are fish. That's a syllogism, and that structure is valid, even though the conclusion is false because
you've
it is
just read
unsound.
that off the internet, haven't you? You've Googled syllogism, and got a
No,
fish one.
But I mean, I hope you get my point,
didn't you?
Paper.
Come on.
Is that's the problem with Betty's challenge to Bev?
No, this is
he's
not
literally quoting word for word from Euclid 28. So the words are there. So if somebody didn't know what was going on, I mean, it appears as though it's a sound argument, but the argument is unsound.
It is deceptive because you are admitting that he's using word line in two different meanings.
Yeah, that's absolutely correct, Paper. That is absolutely correct. That's why it was a challenge to Bev, for Bev to figure out what was wrong with it.
Because if you are going with argument, you are implicitly assuming that the words have the same meaning. Same words have to have same meaning.
Right, in a sound argument, but there's lots of arguments that are unsound. And from the get-go, Betty, you know, Betty knew the argument was unsound, and it was the challenge to find what was wrong with it. And finally,
why would you even bring
Raggedy
up an unsound argument in the first place?
It was valid.
That's ridiculous.
It was valid. He said it was valid, and it is valid.
No, I disagree. I disagree. It is not valid argument. I can disagree with that point that he is saying that it is valid, but maybe not sound. I disagree.
Valid.
It is invalid. Because you cannot use the same word in different meaning, because it is like you used just different word.
Right. It was a trick. Right. It was a trick.
And
it was up to Bev to figure out what the trick was. Right. But anyway,
the trick.
Can we all agree that argument is unsound?
No.
That conclusion is not valid because it's an unsound argument.
No, we cannot. We cannot. This argument is valid and, as you say, sound and true. Yes.
No. Because
because it is.
The implications paper.
You
the
want
implications,
to be,
and I don't know if you've
Charles,
thought about the implications.
You want this to be invalid. You need that.
Well, no. All right. So
this
paper
is valid.
All right. Can we discuss the implications of what you say is a valid sound argument? And that is that no matter where you go on Earth, if you go straight north, you will not end up at the North Pole. Do you agree that you're just gonna keep going and going and going, and you're never gonna reach the destination? Is that? I mean, because that's the implication. Because you've got a bunch of parallel lines, and parallel lines never meet. So I don't think you guys have really thought this thing through.
No, I am talking about second premise.
No. Let's talk about the conclusion. The conclusion is that all lines of longitude are parallel, right?
Yes,
this is
a
sound argument.
Of Betty's argument. Yes,
it was a challenge. Betty does not agree with this. Okay, it was a challenge to you. Betty does not agree. It was his challenge to you.
Did you hear at the beginning where we went over this with Chaiki? Because we went over things that are perpendicular to each other. So we went, for instance, we said a diameter, right? And the tangents at each end of a diameter. Those two lines are perpendicular to the same line, the diameter.
Right, the diameter is perpendicular to a tangent to a circle. Okay,
to
or you said at both ends. Both ends. Right. Yeah, of course.
So those two lines would be parallel.
Right. The two lines tangent
so the
at
logic,
either end of the diameter.
The logic of Betty's argument, right? The entire argument is perfectly valid as it stands for perpendicular. So if you affirm the antecedent, you affirm the consequent. That's the way. That's the way logic works, right?
Okay.
So if it works for a tangent at either end of a diameter, then that's the perpendicular to two straight lines to one other straight line. That's the perpendicular relationship.
Yes, I get that. I mean, I don't agree with it, but let's just say for argument's sake that this is all true.
Okay.
Have you folks here considered the ramifications of all this? Because I don't think you have.
That's why I was saying, what was Betty's intent for bringing this argument? Because, like we say, it does work for certain things. Now, are you going to be the arbiter of the person who can put labels to these lines when it's actually a Euclidean principle argument talking about the relationships between straight lines?
You're ignoring the question. Have you considered the ramifications of this conclusion? Let's,
Which
because
conclusion?
you're taking the conclusion as
Betty's
true.
conclusion.
No, it's not Betty. Betty was challenging you with a puzzle,
no.
and you failed.
Charles,
Betty does not agree with that conclusion.
We don't fail.
Betty does not agree with that conclusion. So don't keep saying it's Betty's conclusion.
It's because of the geometric fact of this, Charles. Because of the geometric fact of it, and me not having a model, right?
What's the geometric fact?
The perpendicular.
What's perpendicular? The latitude
the
longitude
argument. A. If A is perpendicular to B. So you can change this. You can put different things there, right? So you can put tangent and diameter, right? And in that argument, and it would be valid and sound.
Right, because the tangent
it would be completely true.
The tangent and the diameter are coplanar, and they're straight lines.
Okay,
so
brilliant.
Therefore, it's Euclid 28.
Well, you're saying that with saying perpendicular. So now, when you're saying it about, say, vertical and horizontal, which they're perpendicular, just like a tangent is perpendicular to the diameter, vertical is perpendicular to horizontal.
No.
Well, there's a different perpendicular now for these different things. That's why we're saying. That's what Betty's argument seems to be exposing, the fact of difference within perpendiculars.
No.
Yes, but I think that Betty is purposely making mistake, because premise 2 should be premise 1. Because as he said, that you have to start with major premise. And major premise is premise 2, not premise 1. Because premise 2 is general statement about lines. He's not talking about longitude lines or latitude lines. He's talking just about lines. And he is saying that it is referring to proposition 28. So that would be first premise, not second. So not middle term.
But that's splitting hairs as to whether which premise should go first. That doesn't affect the soundness or the validity of an argument.
It does, because middle term would be premise 1, and in order to create syllogism, there is a link between first premise and conclusion, and this link is middle term. So it does matter what is middle term in argument.
So here's a question for you.
He's making mistake purposely. I think purposely he's making mistake.
Well, I mean, the conclusion was false. But Paper, are you saying that if I took a syllogism and I switched the two premises, that would make it unsound or invalid? Is that what you're saying?
In that case, yes, because premise 2 is more general than premise 1. Premise 1 is referring...
I think you're talking about maybe style conventions, but you're not breaking any rules. You can put the premises in any order.
No, absolutely not. I am not talking about convention. I'm talking about generality of statement. So statement premise 2 is more general because he's talking about any two lines. Any means including longitude and latitude and horizontal, vertical, whatever.
Right.
Any two lines.
Yeah, that's
but
why number 2 is false.
Premise 1 is talking about not lines, but lines of longitude. So the lines of longitude are more particular than lines, obviously.
Yes.
So,
well, all right. Let's back up a second and then just talk about a generic syllogism, the world's most famous syllogism. Socrates was a man. All men are mortal. Therefore, Socrates was mortal. Right?
No,
that is the world's most famous syllogism.
You quoted incorrectly. I'm sorry. Syllogism is as it goes.
Slow down.
Or it starts with this is called oh my god, I forgot the word. Categorical statement. It starts with categorical statement because this is most general. So all men are mortal. This is first premise, and this is most general. Then Socrates is a man. This is second premise, middle term. Therefore, Socrates is mortal. This is how syllogism is created. You are just confused.
So you're saying that would it become invalid or unsound if I switched premise 1 and premise 2?
Yes.
No, that was either or. Which is it?
It would be
invalid or unsound?
Invalid because it is formally incorrect in that case.
All right. So like I said, I have not studied logic as a formal study, but
I am repeating what Baby said. She said that it has to start with major premise. This is not my words. Baby's words.
Defer,
So he's violating his own words.
But
here in this
we are still okay. So I'm gonna deflect to the more knowledgeable people. I'm not gonna die on the hill of switching premises. Okay, what I am gonna say is that we are avoiding the elephant in the room, which is the implications of this conclusion. Are you folks suggesting that if you go north, like I think are you from Poland, if I'm not mistaken, you go straight north from Poland, will you hit the North Pole? Will Bev go north from the UK?
Matter.
Will you hit the North Pole?
That's why I put that as a middle term. So
no, what's the implication? I think you're stuck on this on the structure of the argument. Let's just talk. Let's assume that everything's perfect. The conclusion is valid and sound. Okay, so we're going to assume for the moment that this whole structure was a sound, valid argument. Okay? So now we have this conclusion. All lines of longitude are parallel.
Yes.
What is the implication? That means any city in the world, you travel north on a line of longitude, where do you end up? That's my question.
That would be that implication. And that's why this is the point where I disagree with first premise.
No.
Oh my goodness, paper, you're going around in circles with the argument. Let's just assume that the conclusion is correct.
Put it as an angle.
Yes.
Go on, put it as an angle.
Let's assume the conclusion is correct. All lines of longitude are parallel.
Yes,
or do you disagree with that?
If both premises are true, then a conclusion has to be true. I agree.
Okay.
As you disagreed with general premise,
oh my goodness,
premise second, I agree with the premise second, of course, but I disagree.
Okay.
With premise first, which should be premise second.
Okay. Paper. For the fourth time, can we ignore the premises and can we just say, let's say this conclusion is valid?
It's Betty's argument. How do you ignore the premise?
Okay, let's just. The conclusion
just got a conclusion enthalpy.
The conclusion is let's for argument's sake.
You work out how we got here.
The conclusion is sound. Let's say for argument's sake. So paper. Can we move on from this argument and talk about the implications, the geographical implications of saying this
The perpendicular
conclusion
argument
is you're ignoring the conclusion. You're talking about perpendicular argument, but you're ignoring the conclusion.
I'm
we talk
asking,
about the
why did
conclusion?
Betty bring that perpendicular argument?
Because it was a challenge to you.
But what
okay?
what was his aim? What was the end goal
you can ask
for
him.
it?
You can ask him.
Well, it seems
All I'm
like
saying
you,
to you
want to be able to falsify premise 2.
Oh my
You're still
Yeah,
trying to do it.
I'm
You're trying to get us
saying,
to imagine.
I'm going to grant you that this entire argument is completely valid and sound. Now we have a
Absolutely
conclusion.
disagree.
The conclusion is that all lines of latitude are parallel. Okay?
Okay, but
What's the implication?
we can put vertical and horizontal there as well, can't we?
Charles, I cannot say about implication of invalid argument. You say that this is valid, but I spotted that it is completely invalid because...
All right, so paper. Yes or no? Do you feel lines of longitude are parallel? Yes or no?
Lines of longitude, they are not parallel, of course.
Okay,
That's why.
so they are
I
not
disagree
parallel.
with first
Because,
premise, and
okay,
they cannot be perpendicular because line of longitude, as I
because Bev has stated
is
that he
Give
believes
us
lines of
circle.
longitude are
No,
parallel.
Bev has stated that
That was like
lines of
2 days ago.
longitude are just to do with the time the sun comes around.
yeah,
That's
agree.
it. It's not.
Well,
It's
well,
not
you're changing
part
your
of this
tuning.
argument.
A couple days
But
ago
that's
when
why
we
I
had
was
this
saying,
conversation,
Charles, that's why I was saying, why has Betty brought a perpendicular argument and brought in 2 lines that aren't really lines? One's an angle, the other one's time. There's no relation to this. But
Absolutely.
they're both lines.
but the perpendicular argument definitely stirs up some sort of something in you that makes you want to invalidate Euclidean geometry.
I am not trying to validate Euclidean
you
geometry
are.
for the 100th time.
You
okay?
are.
If you
You're
feel I'm
doing
trying
away
to
with the
invalidate
middle
Euclidean
term,
geometry,
Charles.
then you're misunderstanding
You're
what I'm saying.
having the antecedent and the consequent, and you're doing away with the middle term, which is the link between the two, the reasoning part. You're just doing away with it.
No, it was a trick that they
It's
used.
not a trick,
used
Charles.
the word line
The only
in 2 different
trick
contexts.
is what you have had done to you. He set you up, Charles. You're the one that's out here trying to get rid of the middle term of a syllogism. For
Which
what
is
purpose?
not a middle term, in fact.
It was a trick. It was a word game where he used the word line to mean 2 different contexts. One was spherical geometry, where it's a geodesic, or even not a line of latitude is not a geodesic, but it's a curved line. It's a circle.
Okay, right. So
but a line of
we
longitude
agree-
is a geodesic.
Can we agree on axiom 11? You probably won't call it axiom 11, but
I agree with 100%
all
of
right
Euclid,
angles
so-
are equal.
Yes.
Right, okay. Now,
Yes, they're all
you
90
do
degrees.
state, though, that there is a difference between perpendiculars.
No, I never said that.
Okay, right. So is there a
perpendicular-
difference between a
perpendicular-
perpendicular, between a tangent and a diameter, as from a perpendicular, say, for vertical and horizontal? Are they different perpendiculars?
Perpendiculars are always 90. Perpendiculars are always 90 degrees.
Okay.
However,
mean,
you cannot define a vertical from a horizontal. That's where you run into trouble.
But they are perpendicular.
If you start with plumb, you can construct.
Are vertical and horizontal perpendicular, like the diameter and the tangent are perpendicular?
Only if you start with vertical.
What does that mean?
That means you start with plumb.
That's a
and
nonsense.
You can construct. You start with plumb, and you
Like
can
the
construct as
diameter.
many. You can start with plumb,
Like the
and you can
diameter.
construct. You can start with plumb,
Like
and
the
you can construct
diameter.
as many. You can start with plumb,
Like
and
the
you can
diameter.
construct as many.
Tangents. as though they're horizontals from your diameter, which you can imagine as a plumb, in order to relate them together to the actual geometric part. And there's no difference, right? Because all right angles are equal. And since perpendicular is an angle, a relationship of an angle, then they will always be the same, because all right angles are equal.
Yes, so your question was to flat Earth mass. He don't want to answer. He's trying to answer maybe some different question, but this is the problem with globers, that they are not trying to answer the question, which is inconvenient because they know that the answer would lead them to some contradiction maybe. But of course, diameter is, and I am answering for flat Earth math because he went on mute, that the diameter is as same perpendicular to a tangent as vertical to horizontal. They share the same perpendicularity, so to speak. So for me, thing is obvious. And is that for flat Earth math, Charles?
Yeah, the very fact that they are all equal means that it matters not which line is perpendicular to the other. Whereas Charles wants to have an order to perpendiculars, which is ridiculous. But he's got his dogma to follow, I suppose.
And by the way, if diameter is perpendicular to tangent, it means that it cannot be perpendicular to circumference. It is mutually exclusive, because tangent line is different from circumference. You can have only one line perpendicular to another line. I mean orientation. And of course, the circumference is not tangent line. So by definition, or by inferring, it cannot be perpendicular.
Yeah, I think he made a video about that.
So problem, and by the way, he was talking about this mixing spherical geometry and Euclidean geometry. So it is not allowed, and it makes this argument completely invalid, because you cannot do that. You cannot you cannot use different subjects. If you have different subjects, like in this example of all men are mortal, Socrates is a man, etc. So in first premise, you have all men. Men means this is subject, categorical statement, all men. In second, Socrates is a man. You have the same subject, man, particular, but belonging to the same collection. So if Baby is making this line different in first premise than in premise 2, he's violating the very principle of creating argument. It's just he's invalidating his argument, and flat Earth Charles is confirming that. Trick is not the argument. Maybe Baby was doing trick, okay, but this trick is not argument.
It's tricked Charles, if anything. It's definitely not tricked us. I like it.
Yes, and
I like this because it's good stuff for us to go over.
Yeah, and that's why I said to Chaiki, he's playing with you, not with us.
Yeah. Yeah, actually, let's go back to the back to this, because Betty's talking to Charles here, flat earth Charles. He says, if we assume that all points of equal elevation form a plane, and if we define a line of longitude latitude as a set of points of equal elevation and equal angle of longitude latitude, right? So this is it's quite a few ifs building up here. This is Betty doing this. This is a sophist at work. And obviously, team Flat Earth Charles is on Betty's team, so Betty's side applies, and it's like under a spell. So I'll go over it again. If we assume that all points of equal elevation form a plane, and if we define a line of longitude latitude as a set of points of equal elevation and equal angle of longitude latitude, then the perpendicular argument can be made sound and valid. Lines of longitude will certainly be parallel, says Betty. But that first assumption about the plane is crucial. When he said angle, perpendicular, right? That's a plane. If it is false, then Euclid 28 is false. So Betty can falsify proposition 28 by just denying the plane, which is another brave, bold move, right? I mean, again, not for him, but he's handing something to, people of less understanding, right? He's handing them like a gift, a sort of encouragement thing. Because you can't falsify Euclid by denying a plane. Euclid stands. Whether you imagine a plane is a plane or not doesn't make any difference.
Yes, and I would say also that what he is doing wrong, Betty, is applying this Euclid proposition 28 as premise in his argument. This is what he's doing false. He shouldn't do that.
Well, he was just using it for, for that link.
Yes, he did use that. He misused that, but it doesn't falsify Euclid.
Yeah.
So if he's applying Euclid wrongly in his wrong and invalid argument, it cannot invalidate Euclid. Sorry. Making logical mistakes using Euclid, it does not invalidate Euclid. Sorry, this is affirming the consequent.
Yes. And he's not invalidating, he doesn't think he's invalidating Euclid, but I mean, one break in the chain of an axiomatic system, your whole logical structure's exploded. And Euclidean geometry, the foundations of mathematics, is the perfect axiomatic system. Perfectly valid. Each truth follows on from the last, step by step. He says, but first, that assumption about the plane is crucial. But if it is false, then Euclid. Book 1, proposition 28
wait a second. I don't understand. If it is false, what false? Plane false? What he's talking about?
His first assumption about a plane. Like, if we assume that all points of equal elevation form a plane, like, these are all assumptions that he's coming at it with. Like, these are all hidden. But he said perpendicular, so of course he's talking about a rectilinear, plane rectilinear angle. Like, that's pretty obvious. He said perpendicular. Perpendicular is a plane rectilinear angle.
Okay, so if it is false, he cannot say that because it is true. He said if it is false, then Euclid 28 is false. But it is true.
Yeah, you can't falsify Euclid, so it's got to be true. And like, he's just messing up logic, right? He set up some really weird assumptions at the beginning here because he's trying to help Flat Earth Charles here become a shadow giant.
Yes, but he's affirming the consequent. He's saying that if it is false, then Euclid is false.
Yeah.
But what was first, his assumption or Euclid's elements? Euclid's elements were first.
Yeah, that's why I said it's a bold move. Like, really bold. I mean, it's 2023, right? Everybody's forgotten about logic. I mean, can't Beddy have a go at doing this? Do you think he'd pay, you know? I can't believe that there's only us here that he's testing it on. Like, there's nobody out there that gives a shit about logic. They just let people, you know, do whatever Beddy's doing. Just trying to confuse people. It's just like pure sophistry.
But he's making load of mistakes, logical mistakes. He's confusing premises. He's putting a second premise in place of first. He's invalidating his argument because he is misusing the same word in different meaning, which invalidates argument. Now he is affirming the consequent in this statement. If it is false, then Euclid is false. It is affirming the consequent fallacy. It's just, let's say, impressive how he is defying logic.
Yeah, it's all hidden within an internal contradiction that not a lot of people can see. But I'm lucky enough to be able to see it, and hopefully we can let people know, because this sort of stuff's been going on for ages. And once you see it, your eyes become open to it. You'll see it everywhere. Trying to falsify Euclid. And yes, Charles, he is. He's trying to falsify Euclid and the logical structure. Probably one of the most simplest. If P, then Q. But you've got a break in the then. You've just got if P, Q. How did you get there? Don't know. Doesn't really matter. We're here. We got what we wanted. He says, as for Aporema, there is none. Everyone knows that lines of longitude converge at the poles, and everyone knows that north-south orientation is perpendicular to east-west. It follows that points of equal elevation cannot form a plane. What about that for a non sequitur? Do you want me to do it again? It's as if the very word Aporema makes them freak out. As for Aporema, there is none. Everyone knows that lines of longitude converge at the poles, and everyone knows that north-south orientation is perpendicular to east-west. It follows that points of equal elevation cannot form a plane.
Which is, of course, a paradox, because points of equal elevation they have to be on a straight line or plane. Because otherwise you will create paradox.
Isn't that like a non sequitur though?
No, it creates paradox.
Yeah, but I mean, how do you get equal elevation from perpendiculars to north, south, east, and west?
If you have that they are perpendicular, you cannot infer from that they are not straight. They have to be straight. If you have perpendicularity, you cannot infer from that any curvature of the whatever.
I get it. If you can invalidate proposition 28 and have two lines perpendicular to another line, but not have the necessary consequent, then that's obvious that equal elevation cannot form a plane, right?
Yes, yes, of course. This is non sequitur because it does not follow by necessity. Because sometimes people don't recognize that conclusion may follow from premise or antecedent, and it is valid. No, in logic, this conclusion or consequent has to be by necessity only.
So this here is an aporema that he's writing. There's a contradiction in the terms of everything that he's writing down. He's saying there is none, but then writing down one. I like it. Nice twist. I say, is this all about the elevation profile? You know the boys do enjoy their canal posting. Good luck with this. It's a bold move, but if it pays off, you'll be in the history books for sure. Your shadow giant status is almost guaranteed, but will you share it with your friend? Flat Earth Charles. Betty says, nothing to do with elevation profile. Say vertical is perpendicular to horizontal on elevation profiles. Have you attempted to falsify Euclidean geometry by redefining the plane by the inclusion of elevation? Elevation profiles have all horizontals parallel with the heights marked on a perpendicular vertical datum. Does your perpendicular logic apply to vertical and horizontal in the same way it applies to other perpendicular lines? That's a valid question, right?
Yes, absolutely, yeah. And as Flat Earth Math said, he is using in two different meanings. So it means that he is confusing two different meanings of same things.
Betty says, I have certainly not redefined the plane by the inclusion of elevation. My definition of the plane remains the standard definition. My point is very simple. Unless you assume that points of equal elevation form a plane, premise 2 of the perpendicular argument will fail.
No, it will not.
You can never make Euclid's propositions fail. Betty thinks he can do that. I mean...
No, he cannot. He thinks maybe that by misusing that argument, let's say invalid argument, he could invalidate Euclid's elements, this proposition, but he cannot. He cannot do that.
Yeah.
Because this is general statement in premise 2, which should be premise 1, by the way. He said that all perpendiculars, etc. So he's making a categorical statement, which is in Euclid, and then he's talking about longitude lines, which are not categorical statement. So this premise could be falsified, not Euclid's
I think
premise.
To look at it is simplify it, right? His premise 1 is definition 10, the perpendicular, right? And his premise 2 is proposition 28, which states that if two lines are perpendicular to the same line, then they will be parallel to each other. So he's just using Euclid. It's Euclid definition 10, premise 1, boom. Euclid proposition 28, premise 2, right? The link from one to the other, therefore parallel.
Yes, but he is making this mistake that premise 2, which should be premise 1, is just about lines. He's not talking about longitude and latitude lines. But in his first premise, he is using this proposition 10, but he's applying this proposition 10 to longitude and latitude lines, which is or may be questionable. Not the proposition itself, but applying it to longitude and latitude lines. That's why conclusion would be questionable by this doubt about first premise. So I'm arguing about or against applying that to longitude and latitude lines, not by saying that lines are perpendicular.
Yeah. See, I'm coming at it from the perpendicular argument and just wondering why he put latitude and longitude there.
Yeah,
because it just doesn't seem to fit. It seems strange, and I thought it seems like Betty's playing a bit of a game here.
Yes, because if longitude and latitude lines they are not parallel because they are curved, he's trying to prove that they are perpendicular. So he's trying to prove, maybe, or to deceive people, that he's trying to prove that curved lines can be perpendicular.
I thought initially he might have been trying to say that they weren't perpendicular. Right? I thought that was his initial idea, but Charles jumped in with, and then Betty's side rule has to be applied.
I think that he is trying to induce that idea that we have proof that curved lines can be perpendicular.
Yeah, that's what it sounds like to me. Yeah, they're trying to make curved lines perpendicular.
Yeah. Of course, his argument is completely invalid, false, and incorrect.
Well,
nonsense.
Bullshit. It shows itself as a problem, though, the moment you place vertical and horizontal in that relationship, because this longitude and latitude, right, they're just angles, but vertical and horizontal, they are planes.
Yeah,
they do have a geometric structure to them, whereas latitude and longitude not really, like just in the way you can perceive them, but they're just angles to lights in the sky, right? You can perceive that in any way you want.
Yes, you can, because you can use different conventions. So in Mercator projection, they would be perpendicular, but in other projections, they would be not. So that's why I call it questionable. You will not come to firm and certain conclusion from that.
Somehow they envision, I think, in their brain, the grid lines on a map, flat map, regular map, you unfold, bam, a paper map. Somehow they equate that with their sphere, with the curves, and they think that's the same, like sheer dialetheism.
Yeah, like the grid lines. Now they are perpendicular again.
Yeah, exactly.
And they would fulfill this Bedy's perpendicular argument.
Yep.
So there are lines. We forgot about those. So we're like at 6 now. 6 different lines that are perpendicular.
Okay, sorry, I'm go off to bed.
Okay.
It's very late. Good night. Thank you very much.
Night.
Night.
Oh, it is late. I don't know how much longer we've got. Got all the good stuff in there. Betty says,
This is.
Go on.
I was going to say this is dialetheism at minimum, and maybe trialetheism, quadriletheism. Like, start naming things. Quintileism. Yeah, it's getting like ridiculous.
Wow. He says, my point is very simple. Unless you assume that points of equal elevation form a plane, premise 2 of the perpendicular argument will fail. It won't. This is such a simple point. I can't understand why you're not grasping it. The easiest way to start is to ask yourself whether the proposition points of equal elevation form a plane is true or not. Where's that come from? It's not his argument, he's just added it. And now, since it is a proposition, it must be one or the other, which is just made it up. Not proposition that isn't in the original argument. Talk about shifting goalposts. I say, does it need saying that a perpendicular is an angle and angles are plane rectilinear angles? Betty, surely you know this. If appearances count, then from my perspective, you've made an argument about perpendicular, which can either be modus tollens or modus ponens. I know you like to number your lines. What this absolutely genius argument does is present itself differently to anyone with a model affliction. Your argument leaves them in a state of aporia between modus ponens and modus tollens. I particularly like your solution to this model-induced aporema by redefining the plane around latitude, being much more than an angle. Nice touch, adding elevation. It appears that you then linked the perpendicularity back to north, south, and east, west, which paved the way for you to falsify Proposition 28 by curving the plane. The horizontal plane can be established at one point, and that point will be on the vertical datum. Within mathematics, 3 points will define a plane, but that plane will not necessarily be at an equal elevation. Both an equal elevation and a horizontal plane / plane of the horizon have zero slope in any direction. I'm proud of you and wish you well. Hope your shadow is large and well defined. Go in peace with your globe. Beddies, thanks for completely ignoring the question. The question again, is the proposition points of equal elevation form a plane true or false? I will keep asking the question. He's gone. This is where Beddy goes into Nathan Oakley mode, right? He's got an argument. He's never answered why he's brought the argument, what he's done with longitude, latitude. I've pointed out to him, I think they're angles. You know, he's still not explained why he brought this argument for Charles and Chaiki and whoever else to stumble over.
He said something about you curving the plane in his first statement there, whatever that was. What's that all? Who's curving what plane?
Yeah, he's having to attempt to curve the plane. That's how he's falsifying Euclid.
Yeah.
It's very
Good
brave,
luck with curving
very
the plane.
brave. He says, I will keep asking the question.
I don't get it. He's curving a plane.
Whatever now comes in. Anybody else can check this if you want. I mean, we just go from what we've been told and what we know. He says elevation profiles ought have all horizontals parallel with the heights marked on a perpendicular vertical datum. He says, is the vertical datum of 1988 nav NAVD 88, the most commonly used vertical datum in the United States today. A plane. And my reply to that one is the state plane coordinates are in a plane, as far as I know, yes. The UK, all elevations are measured and referenced to a single point on the vertical datum. State plane coordinate system in America, that's right, isn't it?
Yep.
You'd imagine that to be a plane, wouldn't you?
Absolutely, yeah. And 3 points on that plane, would they be equal elevation?
You'd have to ask a surveyor. Whatever says, you say angles must be rectilinear, but Euclid does not define all angles this way. There can be other angles, such as horn angles, that is not rectilinear. Plane rectilinear angles are defined in definition 9. You can check it out, book 1, right at the beginning. Plane rectilinear angles. Just check them, make sure that they're the angles that you know about. If you know of any other angles, let us know.
These horn angles, I wonder.
Horn angles.
How do you measure these horn angles, I wonder?
Clue.
You have a horn protractor?
They're just magic angles. They're angles that you can't measure. So, I mean, how many of those are there?
You use a horn tracker.
An angle you can't measure is, we'll call that a horn angle. Well, okay then. What use are they? Well, they're not. They're just something we made up.
Let's call it a horn angle. Sounds good. Like a rhino.
I say to Beddy, right? I tried to do his perpendicular logic a bit to simplify it for him. If two lines are perpendicular to another line, so there will be only 3 lines, then the 2 lines will either be parallel or skew to one another. Does that sound a little bit better? Skew means they're just on different planes, but not necessarily parallel. But they'll still never meet.
Was that a message that Betty sent you?
Where?
Well, that you read off something?
When?
Oh, just now. I wasn't sure. Like,
no, that was I tried to simplify his thing a bit better.
Oh.
Wouldn't it depend which way the skew is, if they'd meet or not? If the skew was inward.
No, if they're still perpendicular, you can still be perpendicular to the same line. Right? But just skew to each other. They don't have to be parallel. But the planes that they're in would be parallel. But the lines, right? Beddy's cross, for instance.
Oh, that nonsense. Yeah. Okay. Gotcha.
But just at each end of a diameter, if you will. Imagine 2 tangents at each end of a diameter, but then put it into 3D. You can just twist them and turn them, can't you? They don't necessarily need to be in the same plane, right?
Flexible. Yeah.
They're still perpendicular to it, but skew. Not parallel.
That doesn't sit right with me, but okay, well
that's the mathematical term for parallel, but like not in the same plane, or like just tilted a bit off the plane. One of them, if you will.
Right. That doesn't sit well. I don't know.
They can't be parallel, can they?
No.
So what's the term? They're never going to meet.
Well, if they're skewed towards inside, like a vector. Let's say they're skewed inwards, like, yeah, instead of outwards.
Yeah, if they're on the same plane, right, then parallel makes sense because any other one they would meet. But if you're dealing in 3-dimensional space, then one line could go north-south and the other one could go east-west, and you just put 10 centimeters apart from them, each other. Right? They're not parallel, but they're never going to meet. They're skewed to each other.
Okay, now I get this. Okay, gotcha. You separate them.
Yeah.
Yeah.
Yeah, Betty asks me again. Whatever. Betty says to whatever, haha, I see that Bev has referred to the state plane coordinate system, which is indeed a planar system, right? So Betty confirms the state plane is indeed a planar system, similar to the UK grid system. Thumbs up. But he avoided answering your specific question. Getting interesting. The reason he hasn't answered the actual question is this. If he says that all points of equal elevation form a plane, he has admitted to being a flat earther by definition. What? Wow, there we go. He's like Beddy's logic. He's good at doing this. He's the recruiter for the Flat Earth Society. Right? If anybody's listening, it's not flat, don't worry. This is just Beddy. If he says that all points of equal elevation form a plane, he has admitted to being a flat earther by definition. Let's go back to that first bit. I see that Bev has referred to the state plane coordinate system, which is indeed a planar system, similar to the UK grid system. And then a little bit later, if he says that all points of equal elevation form a plane, he has admitted to being a flat earther by definition. I don't know what that says about the state plane coordinate system, but you'll have to have a word with him. Nothing to do with me. Or if he says that they do not, he has admitted that lines of longitude are not parallel. I've already said lines of longitude are just to do with the lights of the sun. They're not really lines. It's just what time the sun comes around and goes away. I don't know. I'm sure he's in his fantasy land. Hopefully he'll be documenting this. Maybe doing something with blue or something. I don't know. Whatever says Euclid book 3 proposition 16. What Euclid described is commonly called a horn angle, which is curvilinear angle. This is proposition 16.
Curvilinear angle.
It's proposition 16. It states that any line touching a circle at one point that's perpendicular to the radius, there can be no other lines drawn at that point that would be drawn that would not cut the circle. That's what that proposition states, and it's like a proof to prove that it doesn't matter where you draw a line. Draw a line anywhere on a circle and make it touch at one point, and then line that point up to the center of the circle, and you'll have a right angle. That's a proof within Euclid. You can do it that way round. Try it. It'll work every time. But that's what that does. It says once you've drawn that line, you can't go to that point and draw another line anywhere that's tilted or whatever, because it will cut the circle. That's what that proposition says. And he says that's the definition for a non-rectilinear angle, like within a proposition. You'd have thought the definitions of a non-rectilinear angle would have actually been in the definitions, wouldn't you? You wouldn't have hidden it somewhere in the propositions. I mean, that's doesn't seem correct. You're referring to the UK national grid, which is a transverse Mercator projection of the globe. It's not. It's measured. It's triangulated and plotted. Scale as well. Not a projection of anything. An actual map to scale. What's it? Whatever. Correct. Euclid gives a sufficient condition for being perpendicular in book 1, definition 10. So Betty knows about the definition of perpendicular, but it's clearly not a necessary condition. What? Euclid gives a sufficient condition for being perpendicular in book 1, definition 10. But this is clearly not a necessary condition. It's a fucking definition. It's probably one of the most important definitions throughout Euclidean geometry. The perpendicular. That's pretty big for Betty saying that. Can someone explain the difference necessary and sufficient conditions to Bev? That's one of his little tricks. I say to Betty, definition 5, book 1. A superficies is that which has only length and breadth. Definition 6. The extremities of a superficies are lines. I believe these planes in reality can be orientated any way you choose. I say to whatever. Propositions aren't definitions. Proposition 16, book 3, does not mention an angle other than a right angle. Betty, well done. Well avoided the question again, 4th time. Asking, is the proposition points of equal elevation form a plane true or false? I say to Betty, I take it you've heard of the transitive law of equality, or axiom 1 of the elements. It states, if A equals B and B equals C, then A equals C. This is the most simple example of a syllogism I could find, and I use this form to present an argument to Blue Marble Science in a debate. Talked about it earlier. It went, the horizontal is an equal elevation. If horizontal is an equal elevation, no slope in any direction. And level is an equal elevation, brackets, no slope in any direction. Then level equals horizontal. Betty. For not seeing an equal elevation being a horizontal, because he didn't see that. He says, congratulations, you have failed the question 4 times. The question was, is in the proposition points of equal elevation form a plane true or false? So let me go back. Horizontal is an equal elevation and level is an equal elevation, no slope in any direction. Then level equals horizontal. Equal elevation? Anyone?
Level, horizontal, take your pick.
Equal elevation. I mean, like, is it a plane? A horizontal plane? Is a horizontal plane
Absolutely.
a plane? Is a horizontal
Absolutely.
plane a plane of equal elevation?
Affirmative.
Yeah, everybody knows this. You'll struggle to get a surveyor to not agree with that. I mean, it's fundamental. Congratulations. So that's not answering the question to him. So I don't know how you answer this question. He's got some sort of fantasy argument that he's made up. Right now he's got to dig himself out of a hole. And look at the state he's in. If you remember, I predicted that I would ask the question 5 times, and on the 5th time you would fail to answer and go away. Feel free to prove me wrong. It sounds like Nathan Oakley, right? He's counting how many times you can try and answer the question to him, and he can just deny it. It's a little simpler what we were doing with Chaiki when the level and horizontal. Bunny.
There are some similarities there, yeah. Counting yeah.
So why going away? Why leave the perpendicular argument you brought from your textbook? Because you can't understand that all angles are measured within a plane. Your inability to understand that these angles can be in any plane and in any location or orientation. It seems that as much as I try to explain, you still deflect from your argument or your inability to replace the so-called falsified premise showed to be the best dogmatician with the most terrible rhetoric. Please try harder to explain your failings. Whatever, a plane is a superficies, but not all superficies are planes. Yeah, we had one floating across the top of the screen. Congratulations, you failed to remember the question 5 times now. 6th time of asking. And going for 10. I said, you sound like Nathan Oakley counting the times you ask an irrelevant question. You do realise you've not answered why you brought the perpendicular argument to the forefront of the minds of the blue marble scientists in the first place. What did you think you would achieve? Congratulations, you failed to answer the question. Euclid 128 is not unconditionally true, for it depends on the figures being on a plane. If points of equal elevation do not form a plane, Euclid is false. He's trying to falsify it again. But the soundness of the argument depends on it being true. It doesn't. Euclidean propositions do not care about what you imagine a plane is. They don't give a shit. You cannot falsify them. If I say if perpendicular brackets plane rectilinear right angle, then parallel. That's your argument you said was valid. Betty says it depends on Euclid 128. Again, which in turn depends on whether points of equal elevation form a plane. So for the 8th time of asking, is the proposition points of equal elevation form a plane true or false? The whole argument depends on this. If you don't know the answer, I have no problem with that. I say, I know the answer. I've answered you many times. I have a proof of the very thing you're now talking about. I'm just trying to work out what an angle, which is defined as being a plane rectilinear angle, why it now matters as to which orientation the plane is in. Ask us again and really think about why you're asking this time. Is this the last one? For the 9th time of asking. The question is whether those points form a plane. And no, you're not being truthful when you say you have answered me many times. Not even once. So he doesn't see an answer. I don't know how many more there are. Check it in case he's done any new ones, but I mean, I think this is good. If anybody does want to come in and have a word with this about this, it may sound tricky, but what we've uncovered here is, well, it's a really simple argument based within Euclidean principles that you can sort of understand, get a bit of geometry, get a bit of logic, get to understand how to, no, there's no more. You get to understand a bit of logic, how the reasoning process works. And of course, there's something a little bit deeper, but I'm not too sure how well it'll come across. It needs to be done one-on-one, really. And to be quite honest with you, I haven't been over it with Spot On yet. So I'd really like to be able to do it with him first, and then I'd feel comfortable letting everybody else know. I'm probably doing that over the weekend. But what we've found here is, we call it a model-induced aporema. The argument is a simple argument about perpendicular, showing that it does work in certain circumstances. Like when you have tangents at each end of a diameter. Maybe Vesica Pisces, the perpendiculars to the original line. Whenever you extend a straight line, whenever you do like a Euclidean proof of ruler-free straight line progression, those lines are all perpendicular to the same straight line and therefore parallel to each other. That geometric principles work. Well, these guys seem to have a problem whenever you link that to vertical and horizontal, which I'm guessing is what we did when we did the realizing Euclid. The water level test was to establish that the straight line lies within the plane and not leaving it. So we established the horizontal plane. So I don't know how many people know about this sort of stuff, and probably most people can do it small scale. But Spot On, me and my lads, we all went together and we've extended a 600-meter horizontal plane. Proven. We've done it. We know we can do it. So we know that the horizontal plane can be established. Now, perpendiculars to that, they can be established too. So maybe Betty's logic, and that's what they're putting away here. There's Charles is coming, Chaiki and all of this, to help ease the way. Because it works both ways, this. If you can contradict, then you can contradict the modus ponens and have the consequent realized. Actually, I don't know how it works with the modus tonens. We'll have to think about that. Falsification of Euclid. It's been a tough one. We'll be working on this. This is this one isn't going away. It's such a simple argument. If perpendicular, then parallel, sort of, to simplify it geometrically. But the question is, since Betty's brought it into the forefront, which lines can you put there that are perpendicular? Which are the allowable perpendiculars and which are the questionable perpendiculars? And how are they different? What's the difference between perpendiculars? Let's look at the time. Okie dokie. I'm probably going to be back on Monday, but although anything could happen, might be able to switch it on at the weekend. go over some stuff. Anybody got any requests for Buster? Oh, we didn't even have an intro. Anyone?
Yeah, there's one song I like of his. I just drew a blank right the last second.
Which one?
Oh my. Okay. Where it's not my fault if you don't want to learn, or it's not my problem. Am I destroying the lyrics there? It's like it's the one where the drone is flying over the channel, and he's singing like, "Hey, it's your fault if you don't." I'm paraphrasing the lyrics, but it's like, "Hey, if you want to come to learn, it's on you to learn. It's not my fault if you don't understand. It's your fault for not understanding."
It's not you don't understand. No, can't be.
Maybe I'm putting two songs together.
Yeah. I'm looking here now. Does anyone know what he's talking about? One chance, probably, maybe. Probably not have one chance for a while. Okay, thank you very much. See you next week. Maybe Monday, maybe over the weekend. Who knows what's happening? But keep an eye out for this argument. Perhaps try it on. See how people react to it. Thanks for watching. See ya.
Confidence in the things that I know. I have enough wisdom to see the logic will be shown. I got one chance to show you what I got. I got one chance to show I'm confident or not. Self-evident reason, deductions and conclusions, and the fools are running away. It's not what you say, it's only what you can prove. You better watch your step, you better mind your P's and Q's. You got one chance, show me what you got. You got one chance, show you confident or not. Don't get caught in the matrix of all of these fakers. Society's spinning, and I'm just here living on the ground. Self-evident reason, deductions and conclusions, logically thinking, and the fools are running away. You're flipping over backwards to show me where you think you are. Your model dictates that you never see too far. Shrinking in the distance, you can do